All right. So this is going to be a AP Calculus review session the night before the exam, 2024. Trying to get the chat going. Let's see. All right. Hello. See various people. I'm still not seeing exactly what I want here on my screen. It's important, not y'all's problem. I'm thinking, okay, so my plan right now is I'm gonna go through like some justification stuff. That's like kind of one thing I didn't do in class on Friday that I kind of wish I would have in a couple of classes. Hello everyone. I am prefer. See, there we go. That is looking more like it. That there. So I know. Let let's see. Oh, I don't know about those settings. Okay, now it says the stream status is good. Okay, so all right, so I'm gonna get in here and okay, first definitely justifying our answers. Glad to hear that. Hopefully, three times as productive. All right, so one justifying our answers and free response. Then also there's I don't know if anybody that had tried to contact me for multiple choice solutions that I haven't quite gotten back to yet. I'm going to try to like respond to those emails while I'm going here as much as I can. I think I'm going to. There was something else I was thinking besides justifying our answers, which I think encapsulates like all the theorems from AB, the various uses and possible abuses of infinity. I'm trying to think. And then probably, questions from if anybody has the like the Saturday version, I would probably like to do that one first. And then probably after that, just like whatever questions. And I definitely have time for pre-calculus. Yeah. So I had a list of these topics, and I left it at school on Friday. Okay, so I'm gonna start off with the theorems from AB and justifying our answers in those situations. And I think if you're in my fifth period class, like we did that in the morning on Friday, but that I did not do that in either of the other two classes. So Okay, so what I'm gonna be doing is the intermediate value theorem, the mean value theorem, and also the extreme value theorem. I might try to dig up a question that is getting at the idea of the extreme value theorem. I know of just the one I'm talking about. It's from one of the practice exams that we did in class that a lot of people ask me about, like kind of later on after that. All right, so the first one, intermediate value theorem. And I had just the right table too. Okay, it's gonna be all right. I'm gonna make a new table. Okay, so I'm gonna go 0 to 2 to 3 to 6. And I want. Okay, so I'm gonna make that 20 and this 8, right? Yeah, do that one for later, and then. I remember how I did this. I said 2 and 3. Yeah. So maybe, okay. Yes, I have not typically made the live streams I've done in the past private. Although I might do that for the pre-cal one yesterday, not because there was anything wrong with it, but just like I recorded a much faster version of that. Yeah, the one yesterday, like I did basically no calculus. We made a formula sheet, but it was basically me putting out a rough draft of something I ended up using to make a video today. And so like I think maybe tomorrow I'm gonna make that one private, or later. Is let's see, it's not liking my bit rate, but I don't know how to control that, so I apologize if that's an issue for your user experience there. All right, so maybe this could be something like, I don't know, 12 or something. All right, so question would be for the intermediate value theorem. Oh, okay, and I might say that f is twice differentiable. Okay, so the intermediate value theorem. Okay, I think the question I would ask on that is, okay, like that. Must f have a critical point on the closed interval? Would it be 0 to 6? Okay. 3 and 4, like the oh, you mean, yeah, the actual multiple choice 3 and 4, not pre-response. Yeah, totally, Bill. I got you. I'm going to do these theorems, and I'm going to be working on justifying my answers. Hold on, I've got something to write on. All right, noted. All right, must F have a critical point? Hey, yeah, you know what? I think that if you're talking about three problems, If you look at the report I shared you, the Google Sheet report, you might see, because I think there were two answers that were wrong on the key on on the Google form answers, because I'd copied it from AB and I thought I'd changed them all, but I don't think I did. I changed it on like the spreadsheet, so the report I sent you should be right. And I think I remember both of y'all, like once I looked at it, that your actual score was too higher than. Yes, the theorems are definitely going to be relevant to BC. All three of these are things that come up regularly. The extreme value theorem even comes up in the context, like in some BC context, like polar, and farthest from the origin. And I'm trying to think. There's another absolute extremum that's a pretty BC situation. But must f have a critical point on the interval 0 to 6? Yes, definitely, because a critical point is a place where the derivative is either 0 or undefined. And I can see that f prime is going from -1 to 1 on the interval 3 to 6, and also from 3 to -1 on the interval 2 to 3. Yeah, totally. The other exams, like a lot of these, I'm probably gonna like switch the question up just a little bit so that it's slightly different, but you could see what the right thing is to do. But yeah, I'll take questions from all the colors of exams. I did lose the sheet that had like my legend of what the file name was against the color. That got lost in the move between my usual classroom and the places I was last week. But it's okay. I can remember most of them. And then I might have to ask you what number one on your particular exam looks like. Okay, so my answer to this one is going to be yes. I'm going to say f prime of 2 is greater than 0, and f prime of 3 is less than 0. And f prime, we need the continuity in order to guarantee this. So I'm going to say f prime is continuous. I probably should give a reason. That would be because f is twice differentiable. The twice differentiability means the second derivative exists everywhere, which means the first derivative is differentiable, and differentiable implies continuous. Now, we don't have to go through that chain of logic with them. We can just say because f is twice differentiable. Yeah, the free response, I'll take all the questions. F prime is continuous because f is twice differentiable. Okay, that's showing the existence of at least one critical point. I might, because it says critical point, and we should probably really reinforce the idea that we know what critical point means. So f prime of x equals 0 somewhere on the interval between 2 and 3. All right, and then I'm going to say, okay, that's pretty much the idea with the intermediate value theorem. We need the function to be continuous. That's all we need. We don't necessarily need it to be differentiable, but if it is differentiable, then we will know it's continuous, and okay, we can apply the intermediate value theorem. If we're trying to show it equals 20, we need to have one value above 20 and one value below 20. That's like the best way of showing it. Here it's above, there it's below, or vice versa, and it's continuous, therefore it must equal the thing that we were above and or below. All right, that is theorem 1. Okay, theorem 2 is going to be mean value theorem. Now this one is where I'm going to try to trick you. It's kind of harder for the answer to these questions to be no. I'll say that now, like the day before the exam. It's kind of hard for this question to have an answer of no and for you to be like expected to come back with a coherent response of why. So if you're asked one of these and you can tell it's a mean value theorem or an intermediate value theorem, extreme value theorem is very different. but I'll talk about that third. If you can tell it's one of those two, the answer is probably going to be yes. Because like the way that we show yes is like so standardized, like with the intermediate value theorem showing it's above and below, with mean value theorem showing the thing is differentiable, and then the average rate of change is just right. That's going to be the idea. So for this one, mean value theorem. Okay, for this one, I am going to ask, must there be a value of c between 0 and 6 where f prime of c equals -4? You know, and then of course give a reason for your answer, justify your answer. If you don't have a calculator, okay, name, I'm obviously not sure who you are. If you're at my school, we've got a calculator you can borrow. That's the bottom line. We will find one. If it really comes down to it, this has never happened, but if we had so many people needing and we couldn't find them, I would sacrifice whatever's going on. I mean, I don't know about, I would probably find somebody that had time to do it, but we would find you a calculator. We would run around the school to find a calculator and hopefully drop it off within an hour, before you needed it. If you don't have a calculator, you can still get a 5. I promise you, I could get a 5 without a calculator because the passing score is only 2 out of 3, and that number of questions you need a calculator on the multiple choice calculator section is less than half. Okay, it's like at most 6 out of 15, I think. And so even if like on a lot of those, even like this is getting kind of into the test strategy, which might have been something I wanted to put on the list. But now we're down to 4 answer choices. Oftentimes, like just kind of thinking about the things that we can think about without a calculator, you might be able to eliminate 1 or 2. So if you were just even blindly guessing on the 6, you would expect to get 1.5 right. Oh, yeah. I've got calculators. But for anybody that's watching that has no calculator and no hope of getting a calculator, you just like eliminate down on the ones that you can tell have decimal answer choices. Do the best you can. Like I know of related rates of questions where we can just use number sense to eliminate the wrong answer choices. Go as far as you can. Give it your best guess, and you're going to be all right. Yeah, that is going to be C between 0 and 6. And okay, and so the answer to this one is going to also be yes, even though it doesn't look like it. And that's what I've seen a little bit lately. I saw that on a recent free response, and then I also put it on one of mine, and I had a lot of people answering no. And I like this question because it's very easy to grade, right? If we see no point, move on. And that's like really snappy and like easy to give the right feedback, right? Like if you're saying no, then you're just like, you're not seeing what we need you to see. Okay, what you need to think is that we went, increased from 12 to 19 to 20. F prime of C equaling -4. The only evidence of that would be like F decreasing. Okay, F decreased from 20 to 8 on the interval 3 to 6. So I'm going to say, okay, well, let's just check the average rate of change. F of 6 minus F of 3 divided by 6 minus 3. That's going to equal 8 minus 20, -12, divided by 6 minus 3, which is 3, which is -4. And then I'm going to need the differentiability of F. Okay, F is twice differentiable, so it's definitely differentiable. I think if they tell you it's twice differentiable, you don't need to say F is differentiable because, but, oh, hold on. This maybe is the one that I was thinking, yeah, F is differentiable. Okay, we also, I believe, need to say that F is continuous here. And I have never really totally understood. I think it was last year that I saw it on the scoring notes. And of course, this was not a problem I graded. It's mostly grading series problems. Okay, that was the milk situation. I spent about half a day on that one. Here we go. All right, find the limit, find the absolute minimum. Where is it? What intervals is it? Concave down? It's on a table quite. Oh, maybe it's in the calculator section. Okay, parametric. Yes, the gasoline pumping guy. Yeah, here it is. F prime equals 0. Yeah, we have to say that F is continuous because F is differentiable. I like if because like just like a slightly stricter. Yes, definitely. There's going to be some serious discussion. I guarantee that. It might be 30, 45 minutes before I talk about any series, but like I promise there's going to be some serious discussion in here. If I know my students, I know there's going to be honestly paranoia about series that's wrongful. Like y'all are good at series, especially compared to like kind of the national average, which is sometimes just like giving up on series. It seems like, at least from the data I've seen. Anyway, also it's number 6 typically, and sometimes people don't get to that one, and I understand that. But all right, so F is differentiable because F is twice differentiable. But I should also say, so F is continuous also, in order to apply the mean value theorem. If you say it's differentiable on the whole interval, that does mean that it's going to be differentiable and continuous. And I guess they want us to just like really communicate that we know that. And I know that I've seen the actual text of the mean value theorem. It would be no if from 12 to 8 to 13. I'm not sure. It depends on what the x values were that would go along with that. Yeah, how do you make sure you don't get a 2? Okay, that one. Okay, I've been having this conversation with quite a few people that are like, borderline 2, 3, and borderline 4 or 5. Okay, there's very different situations. If you're borderline 2, 3, you need to focus on fundamentals, heavy hitters, product rule, quotient rule, chain rule, like taking integrals, knowing when to do integrals, honestly, all the AB stuff, because that's 60% of the exam. If you're between 4 and 5, that's where you need to look at the hard questions, because that's where you're actually going to move the needle. Because if you're already getting 4s, you're probably pretty good with fundamentals. You need to look at the hard ones. It's unpleasant. You're going to get a lot of them wrong. You're going to be confused a lot, but that's where like the growth is. 4 to 5, 2 to 3, it's the fundamentals. I promise. Stopping like missing out on easier multiple choice questions, ones that you don't really want to miss, ones you know how to do, and also missing out on points on the free response. Like, when they say find the particular solution, you better get to separating variables. If they say find the interval of convergence, you need to be getting to doing the ratio test. It's a geometric, both of those are geometric series. If it looks exponential, if it's a number to the nth power, or like something related to even 2n or n minus 1 or whatever, something I guess at least linear in n, that's going to be a geometric series. A calculator issue. That sounds ominous. All right, anyway, so F is differentiable, so F is continuous. Maybe I'll say on the interval 0 to 6. Therefore, yes, F prime of C equals, -4. I've already shown the computation for C in the slightly smaller interval 0 to 6. You should see. I appreciate it, but you should see some of my work from when I was a math student. I was not the best math student ever. But I think that left me in a good position to work with students that were just trying to get by or just trying to like get to the next spot in their math place because I certainly had to figure that out for myself. Okay, that's mean value theorem. Newton approximation is not part of the BC course anymore. It was at one point, but it never was when I taught it, and I've been teaching it for about 10 years. So like, you definitely don't need to worry about Newton approximation, Simpson approximation. That stuff's great, really cool. Honestly, probably really useful. Like if you're going into like very specific fields, but it is not part of that. Why did I use 3 and 6 in the average rate of change formula? Because I noticed that they were going to produce an average rate of change of -4, and they do expect you to be able to do that sometimes. Now, I am going to also point out, I built in a little hint here, and I did this on purpose. And I think that, like always there's like these little tiny hints if you know where to look. If we're trying to show that f prime of c is equal to -4, that means that f prime needs to be shown to be a negative number, which means we need to have shown decrease. And the only place I'm seeing decrease in f is right here from 20 to 18. So I see that, I mentally think down 12, 3 to 6 over 3, 12 over 3 is 4. Yes, this is, okay, I'm thinking yes. And yeah. And so that's where you kind of like get that from. Also, like if you look at 2023, the guy pumping the gasoline, the customer, they asked if f prime equaled 0. And so that was looking for two places on the table where the f didn't change. And so that was like quite a bit easier. Rate in, rate out, free response. I would love to do a rate in, rate out, free response. I love those. It's been a while since I don't know, I gave any on any of the practice exams I had in my class. There was a lot of rate to total. There was like a lot of water filling tanks, tank A, tank B, this tank, trapezoid looking tank. Maybe that was just the graph that looks like a trapezoid. Okay, I am not gonna need this for this one. I'm gonna, I'm thinking. Used one. I'm trying to remember if that one was secure as well. I think because it's just no, I remember this one was this like really weird. Yeah, no, not that one. I'm gonna go back to maybe the 2018 Calculus B. I'm trying to find one of the polar problems where it's like find a place where it's closest to the origin. I would like that. That one was particularly weird. This one had polar on somewhere, but not on that. Let's see, 17. I think I remember being parametric. Nope, it was not, but there was not that either. I would ran into a really good one recently. All right, I don't want to waste too much time. Yeah, I think a lot of people's 2024 prediction is polar as number two, like as one of the calculator questions because it's been parametric so much lately. But I think if you go back and you look at a stream I did about a year ago, I think I was probably also predicting polar then too, and it was not. Um, yeah, totally, Ayushi. I didn't even see that one. We are, like, as the readers, it seems to me like we are overall, like, looking to give the point if we can, if it seems like you're communicating the right word or idea. Sometimes it's stricter than others, as you are well aware if you've been in my class the whole year. you know. Convergence always. Okay, I actually like the series like tests for convergence and multiple choice because we don't have to justify our answer, and I that's my best hope for my students because like I know so many of mine when I ask them like, hey, is this thing converging, diverging, or conditionally converging, they know like almost instantly. And so that's why I want it to be on multiple choice no calculator is so they can just be like, I know that one. I'm gonna take my best guess on the other one, and I'm gonna take the extra minute and a half if I can figure this out in 30 seconds. I'm gonna take that extra minute and a half and spend it on a problem that involves some algebra. With the extreme value theorem, let me write out the theorem for you before I move on to like other justification situations, which to me right now is gonna be L'Hopital rule and improper integrals because I taught my class wrong this year and have for the entire time I've done this. I learned this year, and I graded an improper integral where I guess my suggestion would have flown on the one I graded, but then the one this year it wouldn't work. Yeah, LH probably is fine. you know I know what would definitely be fine would be writing out the whole word, but it depends on are we still writing every time we take a practice test? Are we still writing when the timer hits an hour on multiple choice no calculator when the timer's up? If yes, then yeah, we need to find a way to write less. Yeah, Rohan, okay. LHR in the context of a limit, probably, especially if you've shown the limits went to zero separately and then presented a ratio of derivatives in a limit, that's probably going to get the job done. I think if you show them separately equal to zero and then present the ratio of the limit without mention of Mr. L'Hopital, I think you can still get the credit, provided we're showing everything right. I just wouldn't leave anything up to chance if it's going to be 2023 number 6, definitely. I like that one. I graded that one for like a day, and kind of forgotten about it. I was working with somebody on that one this week. Okay, but the extreme value theorem. Okay. If a function f of x is continuous on a closed interval, then it's gonna have an absolute maximum and an absolute minimum. But where this showed up on one of the multiple choice questions, it was like, which of the following must be true? I don't think it was a could be false. Those could be falses are, who man, they're obviously tough because you have to know everything that must be, or like everything that's true, right? Because must be true, yeah, because you're looking for one that's false or possibly false. But anyway, hello, welcome. And the yeah, yeah, I'd say just the same as any other exam. Just use the exact same strategies you've always used. Like because yeah, you definitely don't want to do anything special. That would be my suggestion. Oh, that was rough. Okay, so if f is continuous, then there exists a maximum. Okay, so then there's going to be an x1 where f of x1 is greater than or equal to f of x for all x on the interval a to b. Okay, and I guess I need to say that x1 is also an element of that same interval a to b. Okay, so there exists a maximum. But that was one of the answer choices was like, there exists a value of k where f of k is greater than or equal to f of x for all x in the interval a to b. And that answer threw a lot of people off because like, what does this even mean? And that just means that there is a maximum, and then there's also going to be an x2, in the same interval where f of x2 is like, it's the absolute minimum, so it's less than or equal to all the rest of the f of x values for all x in the closed interval a to b. And so what this means, because x1 and x2 are allowed to roam the whole closed interval, what we need to do if we're looking for these absolute extrema is we need to check endpoints and critical points. Okay, and for those absolute extrema questions, which I'm kind of realizing, like, I'm sure it's going to come up naturally if I just keep working questions that people request. There's going to be some absolute extrema involved, and I'll just do that then and mention that I'm using the extreme value theorem. Am I familiar with Barron's practice tests? Okay, I am not intimately familiar with them, but I do know that I don't recommend them for my students. I forget almost all of those. Barron's 5 Steps to a 5, Princeton Review, like so many of them. They really miss the mark on the difficulty level. They're either quite a bit too hard, or and that's more common, or quite a bit too easy, which I forget which one that one is, but that's dangerous, right? To have the practice exam book be way too easy and then go into the exam and get walloped. We don't want that. I really like Acing AP Calculus by Thomas Hune. I have the PDF of that. He authorized me, like I emailed him once, quite a while ago, asking if it was cool if I shared it with my students in PDF form, and he was like, yep, that's why I made the book in the first place. What I can tell he did, he's probably a teacher much after my own heart, very similar outlook. He's taking questions he's seen on practice exams, switching up the numbers and the graphs and the nature of the function, but like the question itself is the same and the nature of the wrong answers is the same. And so there's a lot of that. I really love that that Acing AP Calculus book. Referencing 8 and 9 on the Saturday exam. That's something I can do. And, I'm sorry to anyone who is not in my class, the mention of different like color exams and then days of the week exams. I won't be able to tell you like where those came from because those are secure. All right, I'm looking at this 89 you're talking about. Okay, yes, flat, flat, flat. F is continuous and strictly increasing. Okay, flat, flat, flat. This thing must be discontinuous. Okay, yeah, let me draw you a picture of what they are trying to get at here. All right, so f of 0 equals f of a half equals f of 1. Okay, on the open interval 0 to 1, f is continuous and strictly increasing, and I guess it wouldn't have to be a straight line. That would be fine. I'm going to say, okay, this is definitely mean value or extreme value theorem related, but because this thing is not continuous on the closed interval, it is not necessarily achieving both a maximum and a minimum value. So A is out. I would say it's D. Now, strictly increasing. I thought you were increasing if your derivative was greater than or equal to 0. But okay, of these answer choices, it's clearly D. It's achieving neither a maximum nor a minimum. Take it at face value, especially like don't think about it like somebody who's just like living in the fine print in the like worst case scenario. Like I was thinking about like, okay, what if f prime is like totally equal to 0? That then it would achieve both the maximum and minimum. It just would be that same value. But that is not necessarily going to be the case, and that would not fit y'all's definition of strictly increasing. What's an example of using the extreme value theorem in a sample problem? The as far as yeah, no, like you're hitting the. I'm looking at the chat, like related rate, separation variables, like free response. That's what you need. 5 and 25. Yep. Ian, I believe that what you are looking for is somewhere very near my classroom, my usual area, like where I'm supposed to be. What I realized, especially when 5 and 25 added Mr. Marco, especially when I fell asleep at like 7 p.m. on Friday. That way, I realized that it just really had worn me out being out of my usual area. So yeah, Leah. I'm going to find a place where that comes up. I'm not immediately thinking of one, but one will come to mind. I'm sure. I know a lot of problems. All right, so theorems from calculus AB. That was great. Let's move on. L'Hopital's rule. All right, so I am. Can you integrate? Yeah. In general, yes, Ayushi, but you're gonna have to break it into more than one integral. Saturday number 9. I think I know what the situation. I think it's a geometry situation, and they just want you to choose non-existent. Oh, okay. Yeah. Again, they want you to choose non-existent because you're worried about the discontinuity or something, but you're just going to add two rectangles together, and you're going to remember that one of them is going to need to be like representing a negative amount of area, and you've got that. Okay, as far as L'Hopital's rule goes, I am switching up like the rules in my class next year. Yeah, no, 2 over 0 is not going to be a situation in which we can use L'Hopital's rule because we need 0 and 0. So I had this one that was really nice in class on Friday. I think it's going to be the limit as x approaches 1. Yeah, sine of pi x divided by x squared minus 1. This is just like a good example. Okay, so what we're thinking about when we are looking at this, what we want to do is always, when we're first confronted with a limit that's algebraic, we want to just plug in on it and see what happens. Okay, as x approaches 1, I'm going to get sine of pi, and that's 0. X squared minus 1 is 1 minus 1, which is 0. Okay, but I'm no longer doing arrow 0. I'm no more 0 over 0 for me. I'm just not doing it anymore. I'm going to do what they want. The I have reason to believe that the rules might be softening a little bit over the next few years. But I have worked on L'Hopital rule questions where it was really, really strict. Stricter than they are on, or I would say we are on pretty much anything else on the justification. So what I'm going to do is in red, this is going to be my work here. I'm going to show the limits go to 0 separately. I'm going to say I'm going to use L'Hopital's rule. Okay, and then I'm going to take the derivative of the top and the bottom separately. Just finding where the two questions intersect. If you're talking about the intersection of polar curves, you need to be in rectangular mode. Is that what we're talking about as a polar question where the two curves intersect on purple number 2? Yep. You need to find the intersection using rectangular mode. And I'll say like I've done that one quite a bit. You can see me doing that elsewhere. I probably, if necessary, I will bring out the calculator on screen, but I would really prefer not to because it looks great, or I can make it look great if I want, but it's really a pain. And I should have the ability next school year to emulate with a much more accurate thing that's easier to work with. So I'm kind of like, I'm hoping to not have to use CE Mu again. I really don't like it. Very clunky. And somewhere along the way, the keyboard and the screen got detached in the window, and I never have been able to figure out how to get them back together. That's just my own technology incompetence, but I'm taking the derivative of the top, pi cosine of pi x divided by 2x. Okay, I'm going to look at this, think about plugging it in. I'm not going to show it's equaling 0 over 0 or anything like that, but it's going to be pi times the cosine of pi. Cosine of pi is -1, so I got negative pi over 2. That's great. Okay, say that limit equals negative pi over 2. Okay, and walk away. Okay, so that's how we're going to justify our answer on L'Hopital's rule if we are desperate to get the credit. The credit for the L'Hopital's rule, if you're the type of person, I don't know, I didn't have much perspective. I don't know what I was doing the day before I took the AP Calculus exam, but I highly doubt it was like really sitting there grinding on practice problems. Like I mentioned earlier or alluded to, I was at best a decent student, and I'm surprised I had as much success as I did. Looking at kids in my class now and like seeing what y'all are willing to do to learn stuff, I was like, I guess I had other priorities or something, but or I just was able to just get by or something until I wasn't. And that's what we're gonna do with L'Hopital's rule. Let's just keep moving. Let's just get a new page. Improper integrals. Another thing I'm going to once again improve. I'm just going to improve my instruction, right? That's how I'm going to look at it. Is I'm just going to do better next year. Not that I'm going to right any wrongs. It's probably too late for that. Improper integration. I plan to do 2 of these. I'm going to be doing one from 2023, and then I'm probably going to look at another one that would be somehow similar. And is using parametric mode useful at all? I'm sure for somebody, yes. But for me, I have only ever found it useful. I remember last time I taught pre-calculus, I graphed some things under the document camera. It was that long ago. Honestly, your brother, he wasn't actually in my pre-calculus class, but he was of the age to have been in my pre-calculus class. And I remember showing people these curves tracing out and self-intersecting, all stuff I would do on Desmos now. But as far as solving an AP Calculus question, parametric mode is never going to be necessary. Never, ever. So I can say that with confidence. Polar mode, occasionally, anybody that worked that one white free response, I think it was the free response that went with goldenrod, and there was a polar curve and it had an inner loop, and it was find the area of the inner loop. I acknowledge that polar mode might have been useful in determining the bounds of integration there. There's obviously in my opinion, better way to do that in rectangular mode. But if that's what you want to do, polar mode, everyone in general is not helpful. And when I look at a calculator and I just grab one in my classroom and I press X and it gives me theta, I'm like, oh no, and somebody probably was not doing the right thing there. But we did have one question in which that was the right thing to do. All right, improper integration. Okay, BC number 5. I remember it was that one, and I'm on the scoring guidelines right now, so I should be able to find that. 4, here's 5. Area, evaluate the improper integral 0 to infinity g of x squared. Was it 12 over 3 plus x? Okay, now I'm going to be. Eventually, they want me to find the integral 0 to infinity of g of x squared. Okay, the error a lot of my students made was just trying to do 1/3 g of x cubed. That does not work. A few sigma notation. If you're taking the BC test, you're going to want to know some stuff about series. This close to the exam, if you don't know anything about series, don't go try to crash course yourself tonight. Ignore all of those questions, spend all the time on all the rest of the questions, and you should be okay. Especially if you're not having to get a 5, if you're looking for 3 or higher. I know of I feel lost track of this person, but I knew a teacher at a different school in a different district from mine, who had a harder road to get down in Cal BC with her students. It was just it was everything was nothing could be taken for granted, right? She was basically teaching algebra and calculus simultaneously, but to students who really wanted to learn, and so they went nice and slow. And so she said they were frequently doing polar in the last days before the exam, and that sometimes they did series, sometimes they didn't. And when they didn't, what they told the kids to do was anytime they saw the sigma, move on, bubble C or B or whatever your preferred answer choice is. Just bubble the same thing for all of them. And then, yeah, I'm sure, it's not going to be the same form, dude. But yeah, as far as knowing sigma notation, if you don't know it, it's all good. You can still get a 3. Especially if you're really good on your heavy hitters, like I was telling someone earlier, product rule, quotient rule, chain rule, all of your facts that you need to know, and how to take an integral and when to take an integral. If you understand that stuff, you should be able to get a 3. All right, so I'm going to work this improper integral, really focused on justifying my answers. Okay, so g of x squared is going to be 144 divided by 3 plus x squared. Now, what I'll say about this, yeah, 1/3 g of x cubed, that's not going to work. Take the derivative, think about the chain rule. A couple of people tried to upgrade that to something like 1/3 g of x cubed divided by g prime of x. That's even farther from the antiderivative. Take the derivative of that using the quotient rule. Okay, that's what I always tell people. I don't think they always do it though, because once you do it, you're like, oh yeah, that technique is just really not all that effective. What I need to do, it's like fraction. I don't love this. Let's just write it as a negative power. Okay, you might be thinking, oh, it's factorable, I should do partial fractions, but that really only works for linear and non-repeating factors only. Okay, now I'm coming around to a point on this with the L'Hopital rule and the improper integration. If people are wanting, I could definitely do a ratio test situation after this, because I'm talking about infinity here and kind of collecting all of the different ways in which we are allowed to use infinity, and going to illustrate the ways in which we are not. But you just won't see me doing any of these things. I'm realizing now, if what we're saying about improper integration is also true, there's a very finite number of places infinity is allowed to go at all in the free response, and I can tell you those finite number of things, and that's kind of what I'm going to finish my discussion of justification with. All right, so I'm anti-differentiating. My recommendation going forward is going to be that people go off to the side and do the antiderivative with no bounds. and then take the limit of the antiderivative, because that's really that's like the key knowledge. There's this multiple choice question that really gets at, do you know what causes an improper integral to diverge if it goes infinity? It's the limit of the antiderivative not existing. And so like doing this, what I'm going to do in red here, like I feel like is emphasizing that, and also protecting us from having to do endless like limit statements on integrals. We don't need that. That's not, in my opinion, that's not realistic for a high school calculus class. Or, I mean, and I have a lot of respect for the students in my class, but like sometimes the things they expect us to do on a justification level are just not, are more appropriate for the college level class. And like, even if like on a multiple choice level we're able to solve like they are, maybe we're not, we just don't have enough time, right? We need more time. Anyway, I'm going to add 1 to the power, divide by the new power. Okay, you can add a plus c if you want, but this is just scratch work, right? So I'm going to be taking the limit of this, because what makes this an improper integral is that right there, is that infinity. So I need to do a limit. And so that's where I'm just go over here. Let's say, all right, I'm taking the, that doesn't make any sense. Okay, that was bizarre. Showing work, do I have to write out the equation before I calculate problems? Okay, ankle bully, no. Yeah, okay, in your particular example, you do not have to write 6 minus 3. You can write 1 over 3, right? Because we know where you're getting that from, especially if you're integrating from 9 to 12 and it's an average value problem and you divide by 3. We understand what you're doing here. What we can't be doing is like integrating and like saying that integral, say from 9 to 12 of whatever you're taking the average value of, equals a number and then dividing by 3, because that equality is not true. That's what you would call a linkage error, and you got to be careful for those. On a calculator level, because that was also part of your question. The things that we are able to do on a calculator, there's 4 things we're expected to do. Run an integral, a definite integral, run a derivative, a numeric derivative at a point, graph a function on an arbitrary viewing window, and solve an equation. Okay, graphing a function on an arbitrary viewing window is probably so that we can compute the zeros of it, and like that's not really ever our answer. It's something we see on the graph, unless the graph is given to us as like art in the problem. If we're running an integral, we have to write down the integral that we're putting into the calculator, that we're typing in with Math 9. And we do not want to give like calculator notation at all. No y1s, no fn ints if you use a calculator, a TI-83, no calculator speak, standard math notation. If we're doing a derivative, we have to indicate what we're taking the derivative of and what we're plugging in, before we give our 3 decimal answer. And it's always a 3 decimal answer in AP Calculus and AP Pre-Cal. What time do I suggest getting to the school? Yeah, I think 7:30 should be fine. I'll be there a little bit before that. I don't even remember where the calculators are. Last week was a bit of a wild ride. Okay, if we solve an equation, I was also going to say, if we solve an equation using the calculator, we must write what equation we solved. Even if it's just as simple as r prime of theta equals 0. You'd be surprised how much of the worldwide competition or your competition at your school even is going to forget to do that. All right, so we're going to take the limit as x approaches infinity of that antiderivative. Now, negative 144 times 3 plus x to the negative 1, I think would be better to write as a fraction, so we can, just really look at this and think about what's going to happen. Minus negative 144 times 3 plus 0 to the negative 1. Okay, well, as x approaches infinity, that fraction, the numerator is going to stay constant and the denominator is going to grow. So that fraction is going to approach 0, minus negative 144 of that is going to be positive. Veer, you are so right. Maybe I would tell students to aim for 715. I also know I have seen students running in sweaty at 7:59, opened up the scores in July, and they've gotten a 5 with 5 on the AB sub score, and it's just like that sometimes that's just life if you're the age that you're taking the AP calculus exam. So aim for earlier to give yourself some time in case something unexpected happens. And in Lakeway, there's always unexpected things happening. You know how that goes. I'm going to call that 144 times 3 to the negative 1 because we don't have to simplify our answer. Okay, but notice how the infinity here was like very restricted. It's only going as the upper bound of an integral or below a limit. Okay, it is not going on one of those vertical bars on the antiderivative. That's not something we're going to do on an improper integral. I'm realizing, so for 23, wouldn't you substitute to get arctan? I think I know which problem you're talking about, and that sounds right. I'm on that file right now. I'm going to just quickly, Ian, scroll to that. I scrolled way back. It's very zoomed in. Yep, arctangent. Totally. Now, I do think the answer is C, pi over 4, because I think you end up taking the arctangent of 1 minus the arctangent of 0, if memory serves. Okay, now, Will, that is something I can help with. Let me go ahead. If you are just getting worked over by the advertisement, I need to look at those settings and see if maybe I need to tell it to chill on those ads, because that is evidently something I have the ability to do. Insert an ad, delay ads. Okay, well, I'll just... Okay, delayed ads by 10 minutes. No more ads for 10 minutes. Ask and receive. Okay, but we'll have to be turning those on eventually, right? But I do mostly just appreciate everyone being here just for because I know this is going to actually have a non-trivial impact. I'm sure that somebody, for doing extra work on the night before, is going to get a 3 when they would have gotten a 2, going to get a 4 when they would have gotten a 3, or going to get a 5. Okay, Rohan. Okay, that was a little too much. You oversold it on that. It's still delayed for 9.5 minutes, so enjoy that. And maybe I'll feel merciful again later. But distracting and detracting from your learning experience, I'm sure. You gotta see if it was 1 minus instead. No, that would have been bad. 1 minus x squared. You're going and looking up. Or maybe you can, no, I don't think with a minus, that would be bad news. You're probably looking it up in the back of a physics textbook or something. Which is a valid integration technique, relying on other people who have done the work before us. There's nothing wrong with integration by tables, but it's not something we should have to do for AP calculus. There's a limited number of antiderivatives we're supposed to memorize. Usually I'm working on getting you the pink answer key. Okay, now Ayushi, I am sending you one where the first problem is a quotient rule where the denominator is x plus 3. Okay, I think that's pink. I'm pretty sure it's pink. I'm not certain. But I don't have a file on my computer or in my email called Pink Multiple Choice Answers, so I'm going to make one now. Okay, great. It really didn't like that, but I remember what page number it was. Okay, and then Aisha, you're going to want to look at those. Trust yourself. If none of those answers are right, go ahead and let me know that that was not the right answer key. Or if you're getting very few of them right, you got to know. Okay, okay. That's improper integration. Ratio tests, I think I'll just let that one come up naturally. Okay, wrapping up my idea about justifying our answers. I'm gonna conclude this. I was requested the 2023 BC number 6. You can use pen or pencil. I know you. You should use that really nice felt pen. Like I that would, unless you're planning on making major errors. Okay. But if you do make so many errors, just throw up a hand, ask for that extra sheet of paper. I don't understand how it works, but I see a couple every year where there's sheets of notebook paper because they've made errors, and there's like you have to read off a sheet of notebook paper. I don't understand how it gets in there with the scan and how it always they keep track of it, but they do. You can have faith. All right, so infinity. Larger font. I'm going to show you where it's allowed to go in free response, and I'm now proposing that it's not allowed to go anywhere else. Okay, in a limit. Okay, we can definitely have x approaching infinity or negative infinity. That's cool. Of something equals something else, right? That's totally legal, nothing wrong with that. Okay, we can have a limit equaling infinity, so that would be the limit as x approaches something else, and that's kind of a controversial thing. I was in an AP Summer Institute for pre-calculus this summer, and there was a guy that was very upset about that. Over multiple days, it kept coming back. This was a virtual one. It was a little awkward, I would say. But he kept coming back. He was very adamant that like a limit cannot equal infinity because infinity is not a real number, and that means the limit doesn't exist. And I hear the guy. But really, what I always fall back to when people start in on me with that is that in my class, I distribute a notes book, and we take a definition of the existence of a limit. And our definition for limit equals infinity is as x approaches this value, the output values of whatever's going on the inside of the parentheses get arbitrarily large. Okay, I even go with the epsilon. It's not epsilon and delta. It's m and n, something like that. Just like beyond a threshold, it's above your mark. I can make this as large as I want by choosing sufficiently large or close to whatever values of x. But that's what we're saying. We can put infinity there. These are legal. We can also have infinity as the upper limit of a summation, obviously. So the sum, as n runs from 0 up to infinity, that's obviously an appropriate place to put an infinity for sure. Okay, now we're going to probably have something, like that we're adding up. There was an upper bound of integration or lower bound of integration. It could be negative infinity up to something. But I'm just really talking about positive infinity here. So maybe I'm integrating from 1 up to infinity of something dx or potentially y or dt. I can't really think of a situation. I mean, maybe parametric, if we were just thinking about what happened as time went on. It's more of a physics thing to do. I really think... Yes, good point. Pen is not required for the free response. For the free response, nobody's going to know what you... Well, I'm going to know what you use. But, especially if you erase. But you're allowed to use either, but you need to keep in mind that the reader is not holding your physical booklet. The booklet that you are writing on will be scanned, and the reader will be looking at a scan of your booklet on the computer. And while there are, at least to me, impressive tools we can use to enhance the image, it is still black and white. So I always tell my students, I think it was last summer, so I told a bunch of them this year, we saw a response at my table that said, had work. We couldn't tell the difference. It said, don't read the work in blue, only read the work in black, or only read the work in red, or something like that. And it's it's all black to us. We couldn't tell which one it was. And so we had to, yes, Abby, I know exactly what you're talking about. Okay. Well, it's unfortunate the person can't type in the chat, but y'all are supposed to be the experts in this forum, not me. I had to figure out I had to relearn how to stream yesterday, and that was not the easiest thing, but also not the most difficult thing ever either. They make it pretty easy for people like me, who are decent with technology, but not always like totally up to date. That's how I would describe it. I cannot think of another situation in which infinity is appropriate to put anywhere else. So there was one. Okay, occasionally I've seen like a u substitution improper integral where it's like as x approaches infinity, u approaches infinity. That type of note I'm sure is fine. But hopefully we don't see that. Hopefully if we're going to do u substitution and it's an improper integral, that's happening in multiple choice when we already have a 1 in 4 chance of guessing it right. That's what I'm going to say on that. Okay, so, oh, yes, that is why they can't type. If they are in my class and they are still holding out on subscribing to the channel, that is gonna be harmful to their ability to type in the chat, I think, is what I decided when I was doing the settings. Okay, yes, if it's a numerical value that even if you can simplify it to 0 or 1 or trig functions, I will admit today that I have been overselling that to people the entire year. I do it every year. I always say, that's why I always preface it with in my class. I was like, in this class, we have to evaluate logs of powers of E in unit circle trig. That's like I say it all the time during the test and during the year. You do not have to evaluate cosine of pi on the free response. But occasionally, like if you need to, you might need to simplify it to like be able to give a coherent response on a later part, or say determine which of these is the greatest in like an absolute maximum situation, something like that. Trapezoids. Let's do it. Yeah, I'm gonna do number 6 from 2023, but I do need to find trapezoid from a recent free response, from a released free response. Let's do the gas station customer. Yeah, let's do the gas station customer. Okay, Nav, yes. Rohan, yes. If a limit equals infinity, it does not exist. Right? Because like the existence of a limit is kind of like we're getting close to one real number. Okay, but I don't want to get into the details of like the stuff that that's like exactly what we don't have to worry about for AP Calculus, because it's just a Cal 1 class. It's not an analysis class. We don't have to have these like debates or arguments. We don't even actually have to have it multivariable because we're focused on computing stuff. It can be completely unsimplified. Solutions to the multiple choice practice. Okay, if you're talking about the white booklet, that's the Saturday exam. What you need to do is go onto my course calendar. You need to click on yesterday, which is like enter your answers here. I'm going to warn you, there's a couple of wrong answers. And I'm not going to be able to send you the feedback sheet at this point. I sent all of them out this afternoon, and it doesn't take that long. But you can enter your answers into the Google form, and it will tell you which ones are right or wrong. And when would we not get points for a L'Hopital's question? If you are if you're equating a limit to 0 over 0, if you're not attaching a limit to the ratio of derivatives, basically if you're not, number 6 from 2023 is kind of next because it's got a Lagrange error bound for my man Nav, and number 6 from 2023. That one is so easy to really get intimidated by. But if we just keep our cool and just look at hold on just a second. Just look at what they're telling us and just work step by step. It's all right. So t and f of t. I'm just going to be doing this just for the sake of a Riemann sum. So I'm just not going to even be talking about the meaning of this at all. .1 and 135, 0.05 and 150, 0. Okay, this was like the guy pumping gallons of gasoline into his car. So that was a definitely a good problem. They wanted us to approximate the value of integral 60 to 135 of f and interpret the meaning and use correct units and stuff. We're just going to do this with a trapezoid sum. Yeah, and the 30, 30, 50. Yeah, these are going to have differently spaced x's. Okay, I do want to point out that we are only using this data right here because we are only integrating from 60 to 135. Okay, but I am going to do a trapezoid sum on this, and this is different from what they asked you to do on the 2023 exam. Revolution, two curves, point of rotation not being the axis, totally. Somebody requested me to do one on a vertical axis in class on Friday. I don't remember which class, I don't remember which person. I never did it, and I will do one of those tonight. That one was I can just upgrade that to a washer, vertical axis. That's my cat walking around upstairs. It sounded like a person. Not anybody in my house. Trapezoid sum. What we're doing when we do these, just to give you some reminders about context, is we're adding, this trapezoid right here, where we've got a width, delta x, and two heights, h1 and h2. What we do is we average the heights and multiply by the width, right? Because we just kind of find the middle point and make it a rectangle is essentially what we're doing when we average the heights and multiply by the width. So I'm going to get rid of this, and I'm going to say that this thing is approximately equal to average the heights, 0.1 plus 0.15 divided by 2. Average the heights, multiply by the width. 60 to 90 is a width of 30. Plus, average the heights, that's going to be 0.15 and 1 again. Okay, so this probably wasn't the best, but pay attention to the order I'm putting these in, because I'm going in order with the table, systematically. And another width of 30, but then the third one is going to be 0.1 plus 0.05 divided by 2. That's my averaging the heights. Multiplying by the width, 120 to 135, that's 15. And because this is AP Calculus, we will not be simplifying our answer further unless absolutely necessary. Diliana, it's $14.99. It's last minute practice. You know what? All topic multiple choice. Here, let me find it. Let me find it on the channel. I'll show you the video, but it really would be better for you to do at least try to run through some of the questions on your own. I'm being bold and searching on the main. Yeah, I don't know if that's just because I am the one who's logged in here or because I searched really close. It's AP Calculus All Topic Multiple Choice Review. I'm copying the link. I'm going to paste it into the chat myself. Integration by parts, sure thing. Message could not be sent. Didn't like me. I wonder if that's because am I considered a subscriber for 5 minutes? Okay, no, I was able to post on that one. Okay, so Diliana, that was the all-topic multiple choice. I'm going to go off to the side real quick. Before I'm next doing 2023 VC6, but I have also some requests from the Saturday multiple choice, rate in, rate out, washers around a vertical axis, and now also integration by parts. making note of that. Okay, I've got all this. Meanwhile, I'm going to be trying to add the all-topic multiple choice to today on the calendar for you if you are one of my students. Because that's like, I was really proud of that when I made it. That one's a somewhat successful video on YouTube, although I'm sure that the practice exam I hurriedly, it's like, if I, the less effort I spend on them, the more likely it is that it's going to be a popular one. Okay, yeah, BC Quiz 1499. It's an interesting nomenclature. I guess it was the last thing. Unit 14, exam review. Okay, so I'm putting it right here, right above where it says live on YouTube. You know what? I should get a link to this stream and put it on the calendar too. How do you even do that? It's a McLaurin series. I would love to do that. Yellow number 24. Gia, I'm kind of getting a bit of a list, but I'll knock all these out. I don't even know how to share this. Yeah, maybe next year. Better luck next time. I'm just going to save the course web page, and it's just right under there, right underneath May 12th, BC Quiz 1499. That's the all-topic multiple choice. I think if I had a a good head on my shoulders this week, I would have ordered some copies of that and passed them out, but I did not. So, okay, the next thing is BC6. And I think if nobody minds, I'm going to just do my best copying rather than like trying to screen clip or whatever. I think it will be faster. Okay, so I know that I need to check the battery on this thing too. F of 0 equals 2 because I'm expecting I will be going tonight longer than this thing has the ability to stay alive for, so I'm going to need to plug it in pretty soon. F double prime of x equals negative f of x squared. That's surprising. And then F triple prime of x is negative 2x. Okay, well this is not surprising, because they just used the chain rule. I'm not that impressed. I could have come up with that myself. Okay, now they're going to ask us for the fourth derivative of f with respect to x first. I'm going to break out all the commands and do them separately. Okay, the first command is find the fourth derivative, and we're going to use the product rule. Okay, so first I'm going to take the derivative of negative 2x, which is just going to be negative 2, and I'll leave the other thing the same. Then I'll leave the negative 2x the same, and I'll take the derivative of f prime of x squared. Okay, take the derivative of the outside, leave the inside the same, and then take the derivative of the inside and multiply it on the outside. Outside prime times inside prime. Okay, now I've got all of this. That's a suitable expression for f's fourth derivative. Then it wants the fourth degree Taylor polynomial for f. It's set around x equals 0, so I'm just gonna condense that to Maclaurin polynomial. And so that's going to be, okay, I'm looking for f of 0 plus f prime of 0 multiplied by x plus f double prime of 0 divided by 2 factorial x to the 2, f triple prime of 0 divided by 3 factorial x to the 3, and eventually the fourth derivative at 0 divided by 4 factorial x to the 4. Now this expression here gets you no credit, right? Don't expect to get any credit, but what we can do, especially if we're working in pencil, is we can replace f of 0 with, where was it, 2, f prime of 0 with 3, and we've just earned ourselves 1 point, I think, yep, 2 terms of the polynomial, and then then 2 points for the remaining term. F double prime of 0 is the negative of f of 0, so that's going to be negative 2. And then f triple prime is going to be negative 2 times x, which is 0, okay, times something, so that's just going to be 0. Okay, that'll be nice. I'm just going to leave that as 0. You could erase the whole term if you wanted, if it made you feel better. F's fourth derivative at 0 is going to be, that I think I should probably do the work off to the side for, though. To check and make sure that's still visible to y'all. Number 3 on our class is Unit 8. Yes, definitely possible. Yeah, Maya, I was just talking about that. If you roll back to where I was talking about improper integration, and I first did work in red with an antiderivative, I talked about that question. It has to do with the fact that the cause of an improper integration, an improper integral's divergence is limit non-existence in the antiderivative. So the answer to that one is the answer is divergence because of the non-existence of the limit of tangent is the right answer to that one. Okay, but F's fourth derivative at 0, and if you go back and watch that, Maya, and that is not satisfactory, I'll try again. Negative 2 times f prime of 0. F prime of 0 is 3, minus stuff that has zeros in it, so that's just going to equal negative 6. So I'm going to put a negative 6 there, and that is a fourth degree polynomial. That's part A. I'm satisfied. I do think I need that one. CQ 16 on purple. Yes. Okay, that was part A. Let me shrink that up a little bit and move on to B. B is the Lagrange error bound. Nav, I hope you're still around. This one's for you, big guy. Lagrange error bound. This one is super easy. But this one also really informed the way I'm teaching Lagrange error bound now. The scoring notes really and scoring a bunch of these made it really clear. I saw the students that were getting the points. I saw the students that were not getting the points. It was almost like the harder you tried on this, the less likely you were to get the point. All right, so they're telling me we use the fourth degree Taylor polynomial to approximate f of 0.1. Given that f's fifth derivative's absolute value is less than or equal to 15, on the interval 0 to 0.5, use the Lagrange error bound to show that this approximation is within, so that would be like T4 of 0.5 minus f of 0.5, at least an absolute value. The error is within less than or equal to 1 over 10 to the 5. I don't know exactly what they mean by within, I kind of forget, but they did less than or equal to. Okay, so we're going to do Lagrange error bound because they use the words Lagrange and error and bound, but we would need to know even if they didn't. I've got this thing, pardon me, this emoji thing that is on. I realized I just need to make that window slightly wider. Yeah, you're still here. Okay, yeah, I just was covering up the bottom message. And, although I'm sure emoji reactions are important, I don't think they're as important as, me making sure I can read your question. All right, so I'm showing this error. Remember this, that was not how they dressed it up on the problem. But that's what we mean by error, the absolute value of the difference. Error is less than or equal to, it's a fraction first, next factorial. Okay, if we use the fourth degree polynomial, the next power is power 5. So it's fifth factorial, fifth power of 0.5 minus 0. Okay, you know what I'm realizing? I didn't even do my usual thing. I'm using a fourth degree polynomial, n equals 4, centered at x equals 0 to approximate at 0.5. Okay, and that seemed to really help people this year. They're just always writing that off to the side. That was That seemed to be good for y'all. And then, okay, then something goes up here. Okay, I don't even recommend writing the m. I recommend going for it. That's m is the maximum absolute value of f's fifth derivative. Oh, it's at 15. It's always a question, or it's a number they give us in the statement of the question. So there we have that, and they want us to show that that's within 1 over 10 to the 5. So I'm just going to say 1 over 10 to the 5. I would probably, if I wasn't sure what they meant by within, I would probably just take a chance and say that, and then just try to convince myself of that off to the side. So 15, okay, I see that as 5 and 3. Okay, and then 0.5 to the 5, well, that's 2 to the 5 in the denominator, so that's 32. Okay, so I'm going to kill that off. 5 times 3, 8 times 32. Wait a second. Oh, it was like 0.1, wasn't it? Yeah, it was on the interval 0 to 0.1. Okay, so I just assumed that's supposed to be a 0.1, both of those. Okay, I was like, that is not less than or equal to 1 over 10 to the 5. So that'll be a 1, and then this will be 10 to the 5. Okay, and that is certainly less than 1 over 10 to the 5, because that's 1 over 8 times 10 to the 5, so dividing by 8 makes it 1/8 as big. All right, that was the Lagrange error bound problem. That's part B. Let's keep it moving to part C. I think C is just actually an easier version of part A, if you let it be. So yeah, g of 0 equals 4. And g prime equals e to the x f of x. Okay, write the second degree Taylor polynomial for g around x equals 0. Well, I know that that's going to be g of 0 plus g prime of 0x plus g double prime of 0 divided by 2 factorial x squared. Okay, g of 0 equals 4. G prime of 0, realize that might be near my face, or the top of my head or whatever. G prime of 0 equals e to the 0 is 1 times f of 0 is 4, so that would be plus 4x, and wait a second. F of 0. Why is it? Oh, f of 0. Oh, yeah, and I remember a bunch of people made that error, and I was about to do it as well. 1 times f of 0. What is f of 0 again? That's 2. Yeah, that I remember. That was the one thing, and it was like on the next page in the answer booklet, because I graded this one for like not that long last year, but I did spend some time grading it. That was very unfortunate. G double prime of 0. Okay, I need to take g double prime of x. That's going to be e to the x. F of x plus e to the x. F prime of x, because e is its own derivative. I'm going to e to the x is its own derivative. I'm going to be using the product rule and shortening it like that. So e times f at x equals 0, we had to determine that was 2. And then we also determine, so 1 times 2 plus e to the 0 is 1. What was f prime again? That was 3. So 2 plus 3 equals 5. So that's going to be 5 over 2 factorial x to the 2. That was part C, and I think that's all. Now we can do, like, write out the terms of e to the x up to degree 2, and then the terms of f up to degree 2, and then kind of do FOIL. That's an option. What's the original equation, and how did I replace that? Okay, Leah, I would, because I have because I graded this problem, I didn't even spend that much time, but this one really opened my eyes to like kind of a different approach to Lagrange error bound. I'd always told my kids to like memorize the skeleton and write that and then plug in on with all the stuff, but they always kind of messed that up. And I'm looking for something. There, I know I did a recent. Oh, yeah. Here we go. Just didn't go quite far enough back. All right, Lagrange error bound. For Lagrange error bound, I'm going to recommend that video. That's my new lesson on Lagrange error bound. It is not long. It is only 20 minutes, but that includes quite a few examples. Then I also went in and re-recorded the solutions to my homework on Lagrange error bound. That's part one of the solutions. If you roll to the end of that one and you still want more examples, you can get to part two. If you want the original five, this might be more than you were looking for from me on Lagrange error bound, but better to provide too much than too little. So I'm about to throw something else in the chat, which is a link to my course website and the page that corresponds to like the day we did Lagrange error bound. You will see notes, homework, quiz, video stuff all over the place. Pretty much whatever you need on Lagrange error bound. And that's true for anyone else who is interested in Lagrange error bound, but I think most of the people in here are like in my class. Where is it? Analytics. Wow, we've had some good traffic through here. I'm really glad to be, working with, and the thing is, I think I probably need to get into doing this more on like Sundays before like a unit test, because like the odds of me getting over 50 people in my room for Katie, I will do that one real quick because that one's partial fractions, and yeah, I can do that one. But the odds of me getting 50 people in my room before school for tutoring is just like zero. That never happens. I never have people sitting on the floor. Yeah, I've got two of them that are wrong. If you let me try, I can't figure out how would be the best way for me to. I could show the right answers, but Veer, no, Christian. That is devious. Maybe in the past, maybe in the distant past, but no, they're not trying to mess with you like that. What we want is if you're in degree mode, we want the answer to be a little ridiculous, like very close to zero, very close to 0.5, like kind of like wait a second, make you suspicious. And one of the things we can do to make you suspicious is it not be one of the answer choices. So yeah, no, you don't have to worry about being trapped into thinking you're in the right mode by one of the wrong answer choices. Like I said, that's almost hateful. And we want you to show your calculus knowledge, not get tripped on degree radian mode. And that's why we will be both there at 7:30 or earlier tomorrow, just to remind people to have their calculator in radian mode. All right. Okay, if you notice that the denominator of the fraction that is your integrand is factorable, that should activate knowledge, a and b, partial fractions. Okay, so 3 over x and x plus 1 is going to equal a over x plus b over x plus 1. Doesn't matter which one you choose to go over which, you just got to be consistent. I'm going to multiply both sides of this equation by both denominators. And that will leave me with 3 equals a times x plus 1 plus b times x. I'm going to let x equal 0, and that's going to give me 3 equals 4a. Interesting. Okay, I don't remember this one, but let me make sure. No, 3 equals 1a. Okay, I was like, I do not remember that working out that way. When x equals -1, then I'm going to have 3 equaling negative b. So b equals -3. All right, so this original integral here is now going to equal the integral of a is 3, a went over x, b is -3, and b went over x plus 1. And these are fractions I can anti-differentiate. I'll throw in a plus c, and that'll be my antiderivative there. Rate in, rate out at Finley has definitely been requested. I think that's going to be the next free response that I do. I'm going to switch over to some multiple choice here in a moment. I am logging, Ian, your request of 23 and also Ayushi 27 pink. Oh no, I see. I have got a note on my notepad that says, okay, it was after Gia, but it just says purple. It doesn't say what number on purple. Rohan, there you go, 16. Purple 16. All right, I'm going to take a break for just a moment, and I've run out of water, so I'm gonna get some more, and I don't know, 30 to 60 seconds. Oh yeah, yeah. I usually I if that's the one I think it is, that one's really nice, and I will do that one first. All right. Going to the Saturday exam. I'm going to be doing quite a few from the Saturday exam. Over here on the multiple choice, seems like it's mostly no calculator. That's a good sign for me. That was kind of what I saw in my data as I would like the last. Oh no, this one's tough. I've got an imitation version of this question that I think I'm going to do instead. And hopefully that is close enough for you. I don't know it when I see it. Not gonna spend too long looking for it, but it's got a straight line on it, so it can't be that hard to find. Let's see, did I use it this year? Probably. I really like that question. Yeah, oh, no, it was the exact one. I just snuck it on there. Okay, well, I know what to do. I don't think it will change the nature of the problem if I change the y-intercept. Okay, so the y-intercept is -3, and the x-intercept is going to be, let's say, 10. Okay, if you see what I'm saying. And the graph of the function is shown for -10 to 20. Let g of x equal the integral from 0 to x of f of t dt. Okay, I feel good about this. When is g negative and decreasing? Okay, g of x is negative when I integrate and get a negative number. Decreasing. Oh, wait, this one is not as difficult as... I've got another version of this one. Is this the exact same? Negative and decreasing. Okay. I thought I've got. There's one similar to this that's much more difficult. G is negative from. Okay, when I integrate forward, I'm adding negative area, so it's going to be negative definitely from 0 to 10. But then it's still going to be negative as I add areas until I balance it out. And I can just see from the drawing that I won't be balancing it out until 20. Okay, so G is negative from 0 to 20. That's what I'm saying. And then G is decreasing when g prime of x is negative. Now g prime of x in this case is f of x, okay, is less than 0. Okay, well that will be when x is less than 10, so that's negative infinity up to positive 10. Okay, and so I'm looking for the overlap of these two when it's both negative and decreasing is going to be, let's emphasize on the graph here, when it's both is going to be this spot, 0 to 10. So my answer would be negative and decreasing, 0 less than x less than 10. Okay, and that is how I did that question. Refresher on logistic differential equations, solid idea. That might be one of the last things. That's definitely not one of the most important things from AP Calculus, but it is something that's easy to forget about. That's a solid idea. Okay, rate in, rate out for sure. Kind of going back a little bit. Okay, did that one. Okay, I'm gonna go, okay, kind of back to the top. 3 and 4. I think 3 and 4 might be the ones I missed. Bill was the original one that pointed that out. But okay. X of t is going to equal, we're going to make it equal t to the 3 minus 3t to the 2 plus 20. And then y of t is going to equal the square root of t squared plus 9. And then I'm going to ask you, what is the rate of change of y with respect to x? This is the way they asked it. At t equals, I'm going to say 4 is going to work best for the way I've set this problem up. I looked at the previous free responses. How come we don't have any Lagrange error-bound questions? There was one on 2023 BC number 6, and I worked that one just a few minutes ago. That was a Lagrange error-bound question. It also shows up in multiple choice sometimes, but it'll either be one or the other. It's not going to come up twice on a given BC exam. That would be too much Lagrange. It's only one topic, so they're only going to hit you with it once. So what we need is dy dx here. And so dy dx equals y prime over x prime. We're really interested in dy dx at t equals 4, but I'm going to need to take y prime of t, and that's going to equal 1/2 of that thing to the negative 1/2 times 2t for the chain rule. X prime of t is going to equal 3t squared minus 6t. And then I'm going to get y prime of 4 equaling 1/2 of t squared plus 9, that's 16 plus 9 is 25 to the negative 1/2, times 2t is 8. X prime of 4 is going to equal 3 times 16 is 48 minus 6 times 4 is 24. See, this is why I make y'all do some arithmetic on the free response. 1/2, 1/5, 8, that's going to be 8 over 10, 4 over 5. So dy dx is going to equal 4 over 5 divided by 24 would equal 1 over 30 in this case. Now, I did switch up some numbers from the original problem, but that's how you do it generally. And I think if you take this strategy and you reapply that to number 3, whoever it was that asked, I think that was one I just had a wrong answer on or something on the Google form. Anyway, snow is falling at a rate. I'm pretty sure this one I had wrong also, but the rate is r of t equals 4e to the negative 0.1t, and we want to know that's like the rate of snowfall in inches per hour, time in hours. What's the total amount of snow from time 0 to time 5? Pardon me, from time 0 to time 3. So I want to take the integral from 0 to 3 of r of t dt, because that'll give me the total. If I'm given a rate and I want a total, I'm going to take a definite integral. Okay, from 0 to 5, I need to do that. Pardon me, 0 to 3 is what I meant to say, 4e to the negative 0.1 t. Okay, that antiderivative is going to be 4e to the negative 0.1 t. I just have to worry about that negative, I don't know why I wrote that. I need to worry about that negative 0.1. I think I'm going to divide by that to appease the chain rule, right? Because, yeah, it's going to be its own derivative times negative 0.1. Yeah, that will take care of it. I don't really love the way I've written that number out, but it'll be all right. So negative 4 divided by 0.1 times e to the negative 0.3 minus e to the 0, which is 1. Okay, and if we had to work that around, 4 divided by 0.1 is going to be 40. So negative 40 times e to the negative 0.3 minus 1 is going to equal 40 minus 40 e to the negative 0.3. Okay. And I think that would, if you looked at how I changed the numbers and everything, you'd be all right. Okay. Finley, I'm sending you pink and also gold. Green in the other one, that will take a little while, but I should be able to do that for you also. Okay, I'm going to go back over here. I'm noticing, okay, oh, tomorrow at an AP Pre-Cal. Okay, no, wait, no, that's just great. Okay. I'm trying to click through this. All right, I think that's enough. I was checking back through on commentary. My AP Pre-Cal practice exam video has generated a lot of commentary, lots of accusations of wrong answers, only some of which are accurate. Actually, I'd say probably less than half. The Saturday free response, yeah. Let me see. Yes, I have them. Okay, I just sent the Saturday free response to the wrong person. Hudson sent it to you. He did not send it to Ayushi. I just almost sent it to Ayush. Ayush has been gone for a long time. Ayushi, I hate to admit it, but I think I thought your name started with two A's. Translating equations to series sum equations. Sure. Polar slope, yeah, that would probably be a wise idea. Okay, I'm going to, maybe with any luck, maybe one of these requested multiple choice questions will be exactly that. That's kind of hoping for that type of serendipity. That happened a lot last year where, if I kept doing what people requested, eventually I just hit everything everybody wanted. All right, so we're going to make this e to the 2x minus y equals x, y to the 4 plus pi squared minus 1. Okay, and we want to know what is the value of dy dx at the point. That's going to be tough. I'm going to need to go ahead and make this at the point where x equals 1, and y equals 1. I'm going to need to get rid of that and be flexible on this. Dy dx at 1 and 1. All right, now I need to think about what is going to happen. Okay, e to the 2 minus 1, 1 plus e to the 2, so I need to make that minus 2 there. Okay, so now this equation works. I want to know what is the value of dy dx at the point where x is 1 and y is 1, and I'm going to make sure that y'all are able to see that. Yes, you are able to see that. So I'm going to take the derivative of both sides with respect to x. So with respect to x, the derivative of e to the 2x is 2e to the 2x. The derivative of y with respect to x is dy dx. This is a product, so I need to use the product rule. Derivative of x with respect to x is going to be 1. Leave y to the fourth the same. Then I'm going to add in, leaving x the same, taking the derivative of y to the fourth with respect to x. The derivative of y to the fourth, it's like f of x to the fourth, 4y to the 3 times dy dx for the chain rule. And then the derivative of e to the 2 and negative 2 are both going to be 0 because those are constants, so I'm just going to stop there. Okay, if I was solving for dy dx in general, I'd collect everything with dy dx to one side and push everything that didn't have it to the other, factor, divide, all that stuff. But that's not going to be necessary because I'm just plugging in x equals 1, y equals 1. So this is 2e to the 2 minus dy dx, which is the thing I'm eventually solving for, equals y to the 4 plus 1 times 4 times 1 dy dx. I'm going to add the dy dx to both sides. And then I'm going to subtract 1 and divide by 5. I think it'd be alright with y'all if I did that in one go. And then I will get an answer, and I think you would be animations fan. I cannot. Also, if you think about it, the odds of me seeing a particular person's paper are exceedingly low. That said, I will admit that year before last, I did see one of my own students' papers go by, and you know, I'd always worried about that, and I was able to score it fairly and accurately. Honestly, this one particular student, I was just like, I was really just kind of say like kind of surprised that she had gotten like all the parts, and I was really excited, so I clicked in to view the rest of the booklet, and she just like crushed the whole thing, and sure enough, when I got the score back, it was higher than I had ever thought possible. But that was a good studier, and good luck, and extremely distinctive handwriting, like the most distinctive handwriting. Because I'm going through thousands of exams, and I am going to be grading this year. But and also, I don't know which version I'll be grading this year. Like last year, I graded mostly Form Z, which was like I don't know when people took it or where, but there was not very many of them. Is what I was. There's like very few exams, and so obviously. Honestly, I think she succeeded because of herself, because she took like a C in the class. You know, like I think this was like kind of took it on herself in the last couple of weeks. I have a lot of kids that ended up doing that, especially this year. I saw like I don't know if any of y'all are in here, but I saw some people really make up some ground in the last 2 weeks, and I was nervous. I mean, I was telling other teachers, I was like, I don't know about this group of calculus kids this year. Like, I don't know if we're making that much progress on the practice exams. But a lot of people, the progress was between the second and the third practice exam. Actually, when you went to do the retest, the makeup, that was when you really showed the most improvement. All right, moving on. Number 25 on this Saturday exam, I just scrolled right past it. Volume of a sphere is increasing 4 pi cubic centimeters per hour. At what rate in centimeters per hour is diameter increasing with respect to time? That's weird. At the instant that the radius of the sphere is 2. Okay, they're going to note that the volume of a sphere is 4/3 pi radius cubed, and I guess it is important for me to remind you that that's not an equation that you got to walk into the exam with. I was gonna retitle one of my videos to make it more searchable, and I feel like I've missed out on some possible searches right now. I'm just gonna do it right now. BC formula sheet. It's not a very descriptive title. I could edit that to possibly catch some search traffic right now. AP Calculus BC. Okay, I don't like the titles that have the all caps letters in them. Something about that feels off to me. But I recognize that that works for other people on YouTube and nothing against them, obviously, but I just don't love that. But I will use smarter words that I know people are putting in the search bar right now actively, as my analytics are clearly showing. This is 4 pi r squared dr dt. Today is a day for calculus, and I guess pre-cal also. I really wish that I just didn't think ahead and like really try to sell the other pre-cal teachers on doing this. I bet next year one of the pre-cal teachers at my school ends up doing this, because this is always like a very productive thing. I think I did this one other year, like way in the past, but it was just like a much smaller event with like 3 or 4 people. Back when I was in a previous result, like 6 or 7 years ago. I used to do live more often back then when we had like the flexible instructional time, but kids couldn't always come to my room. I would just put it on YouTube Live and take tutoring questions in the middle of the day, and that was a really nice thing. In some ways, the genius time. All right, dv/dt, that's equal to 4 pi. That's going to equal 4 pi. Radius squared is 4 dr dt, so I feel like that means dr dt needs to equal 1/4. They didn't ask me for dr dt, they asked for dd dt. Diameter equals 2 radius, so I take the derivative of both sides with respect to time. Okay, so in this case, it's going to be 2 times, I determined that dr dt was going to need to be 1/4 for 4 pi to equal 4 pi. And so that's 2 times 1/4 equals 1/2, and that will be all there. No, they will give you the formula for the volume. They don't need you to know that. What we do need to know is the area of a circle, the area of like the area formulas that go with the area volume problems, like the cross sections or isosceles right triangles. We need to know that's half a square, so it's 1/2 x or base squared. Area of a square, obviously, area of a rectangle, area of a trapezoid, area of a circle because of the notion of discs and washers. But for the volumes, they're going to like a cone or a sphere or something. Maybe not a cube. I think they want you to know what the volume of a cube is. I've taken that. I one time on a related rate test, I did not put the volume of the cube is given by v equals x to the 3 or whatever, and I took that question enough times that the next time I asked the volume question of a cube on my calculus test, just for my own sanity, I put that note in there. But I should have put it with like some snark, be like obviously the volume of a cube is given by v equals x to the 3. Solve the word problem. I don't know which word problem you're talking about. If I did, I would solve for you. I'm going to move on. 20, which one was that? That one was 25. 23 was requested. This one's going to be tough for me to do. I'm going to, let me make sure. I know what to do. Okay, I'm going to work number 23 from the Saturday exam for whoever requested it, but I'm going to turn this into an improper integral. Yes. And I will admit, this one's going to turn out a little differently from how this one turned out on the actual multiple choice, but like trigonometrically, it's on a trig level that it's going to finish differently. Okay, we need to recognize, like, we don't know what to do with this. This must be U substitution. This isn't like a product. You know, it's not a factorable denominator, so it must be U du. I'm going to let U equal the inside of the composition of functions, right? That thing squared. So U is going to equal e to the x minus 2. And this is good because I see that e to the x on the outside, which is going to be the derivative of U. So du is going to equal e to the x dx. And that happens to be exactly what I've got. Okay. I'm going to convert my bounds. When x equals 0, u is going to equal e to the 0 minus 2, which is negative 1. And as x approaches infinity, u is also going to approach infinity. Okay, when I make that transform, I'm going to be integrating from negative 1 to positive infinity on 1 over 1 plus u squared. And then that e to the x dx becomes a du. And I'm going to say, all right, that antiderivative is arctangent of u. Okay. Oh, I forgot, I'm trying to model what I am suggesting, that we only use infinity as the upper bound of integration or below a limit. So that's going to look like me saying, checking conditional convergence. That sounds like a solid idea. I did one of those, probably not in your class. Or maybe no, I did. I know that was one of the days you were taking an AP exam. I did go over that in all 3 sections. Anyway, I'm gonna go off to the side and say antiderivative of 1 over 1 plus u squared du is equal to arctangent u. Okay, then when I'm going over here and needing to take a limit, I'm going to be like, okay, limit as u approaches infinity of arctangent u, and we do need to know how to do that one, minus, okay, arctangent of negative 1, plugging in the bounds. Okay, anti-differentiate, plug in the bounds. We can't plug in infinity. We're making it a limit instead. Might just do that off to the side. And then say, okay, I'm taking the limit, I'm subtracting, and then that's going to equal, limit of arctangent is going to be pi over 2 minus the arctangent of negative 1 is negative pi over 4, and I do plan on going and like explaining why that is. I know it's negative 1 on the original, but I can't exactly copy the original. That one's a secure exam. So I'm going to do a related but slightly different question, but I will show you how to find the arctangent values you need. And I'll also tell you the right answer is C. But I changed it to -2, so it was still like something I could find on the unit circle, but it wasn't exactly the same as what we had on the secure test. Okay. But over here, oh yeah, thinking about arctangent. Okay, remember arctangent takes its values. And just try that again. Okay, that's as good as I'm gonna get. Okay, that's my half circle. That's where arctangent takes its values from. So when I say where on the, thank you, Shreyas, like just for the work you've done this year. It's been honestly pretty impressive. But you've got this. I don't think you need too much from me. When I say where on the unit circle is tangent most obviously equal to -1. Okay, that would be down here. But we need to know that arctangent takes its values between between negative pi over 2 and pi over 2. theta, maybe would be a better way of saying that. Okay, so the most obvious place on the unit circle where arctangent is -1, that's the first one I did. That was down here at theta equals -pi/4, and that's why I got that value here. But then the limit as u approaches infinity of arctangent of u. We're thinking where on the unit circle, what arc most obviously gives us tangent approaching infinity. It's like, oh yeah, tangent does have vertical asymptotes, and that would be up here. Okay, that's theta equals pi/2, because think about it, as I'm approaching pi/2 on the unit circle, sine is getting closer to 1, cosine is getting closer to 0, sine over cosine is getting closer to infinity. The arc whose tangent is getting closer to infinity is an arc who's getting closer to pi/2. And so that's why I got pi/2 here, and I'm going to leave that one at that. That was good discussion. Okay, I also have, okay, I don't have any more on Saturday. I do have yellow 24 for Gia, purple 16 for Rohan, and pink 27, I forgot to write down who you were, but somebody who is, I'm pretty sure, what? Oh, I thought you were asking what is the sigma. I was like, you know what the sigma is. I know who you are, and I know you know what's up. Is the emoji thing is just not exactly what I want, blocking my view. All right, let me go in here for a second. I don't even know where it's supposed to have a. Is it another window? Oh boy, I don't even. The thing that I don't know how to get back to is the like. Yeah, is the real studio thing, but it's all good. And then, all right. Hate to do it to you, but you know, if you didn't get the hint, there you go. Have at it. The so losing track. I did the multiple choice, so I'm going for yellow 24. What was round 1? I know where to look. Because that one I'm not totally remembering. Oh, but I need to know who had yellow. Alright, I'm gonna... pretty sure this is the right one. Yellow 24. It's a Maclaurin series question. Yeah, I remember Gia saying that. Yeah, okay. I'm on number 24, the correct number 24. I gotta think. So f prime of x is equaling cosine of x cubed. Okay, and f of 0 equals 1. I'm going to ask for the first 4 terms, first 4 non-zero terms of Maclaurin series for f. Okay, what I'm going to do is first write down the first 4 of the Maclaurin series for f prime, or maybe I'll just need the first 3. But actually, I'm going to need to do that after starting with cosine. Cosine of x equals 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial minus so on. Okay, if I want cosine of x cubed, I'm going to just plug in x cubed all over the place and simplify. So 1 minus x to the 6 over 2 factorial plus x to the 12 over 4 factorial and so on. Okay, that's f prime of x. So if I want f of x, I'm going to anti-differentiate. There's going to be a plus c, 1x minus 1/7 x to the 7. So x to the 7 over 7 times 2 factorial, which should be 14, plus x to the 13 divided by 13 times 4 factorial, which is just going to be some huge number. And I recognize that this is somewhat different from the question you asked, but this is as close as I'm willing to go. F of 0 equals 1. That does mean that C is going to need to equal 1 in this case. And so, all right. Our tangent of 0 is indeed 0. 16 on the purple. That you're up next, Rohan. I already had you on my list. And then I'm going to be doing pink number 27. Purple. That was on round 2. Derivatives of inverse functions. I have not. But I bet I can find one on purple. I am... went with purple, it was green. Rohan, can you describe the purple number 16? Is it a sum of a series? Yes. Well, I don't know if it's Ridom. Most of I would say over half of the people in here right now are current students in my class. Owen, no. Maybe not no, Owen, but probably not. Isn't it? Okay, then I'm looking at the wrong exam, and then I can definitely get you what you need. Oh yeah, we got this. Let's just step up the difficulty on this a little bit. Let's do tangent of x times y equals 2y minus 3. Now I'm going to need to know about, how about x is pi over 4. Oh, I'm going to need this to be, no, we're going to have 2y minus 4. I see the way this equation works. We're going to need x equals pi over 4. Nope, x equals pi over 2 and y equals 2. This is going to be bad news. Secant squared of x, y. No, it'll be fine. Just need to have faith. It's going to be fine. All right, so I'm going to take the derivative of both sides. I want it's dy dx at this point. So take the derivative of both sides with respect to x. Chain rule. On the outside, I've got tangent. The derivative of tangent is secant squared. The inside stays the same, and then I multiply by the derivative of the inside for the chain rule. And that's going to equal the derivative of 2y minus 4, which is going to be 0. And then I'm going to just plug everything in because I'm not actually going for dy dx as an expression. I just want the value. So secant squared xy, that's secant squared pi, multiplied by y plus x dy dx equals 2 dy dx. Okay, this is interesting. Okay, secant squared pi. Cosine of pi is -1. So secant of pi is 1 over -1. It's still going to be -1. If I square that, though, I'm going to get +1. And so I'm going to get +1 times this. So again, 2 plus pi over 2 dy dx equals 2 dy dx. Don't love this algebra. I'm going to bring this dy dx to the outside. I'm going to factor it out, pi over 2 minus 2, and I subtract that one over to the left side, and then I'm going to subtract the other 2 right here to go there, and then I'm going to get dy dx finally equals -2 over pi over 2 minus 2. I may have irreparably damaged that problem by changing it off of the secure one. But that's what I've got. Oh, and while I was working that, I was trying to think about Katie. I can definitely do that one. That volume. I'll do that one right now. I think that was the one you were talking about from the unit test. I think. I'm trying to think of a situation where they approximately like really matters. It would be if we were like comparing the real one, if we knew the real one. I've been doing a lot of pre-cal lately where there's a lot more approximations, like than you would expect, like with regression and stuff, with the modeling. I don't know. I'd have to think about that. But Owen, what I'm telling you is you don't need to worry. Like, don't even worry. Use equals, use approximately equals. You probably know best. Like when you're supposed to use each. You've got this. Can I do some UDV? Yeah, there. I will find an integration by parts because that one is definitely on the list of requests. Okay, I'm gonna move on to pink 27. I don't know how, but I determined that pink. Oh no, I know which one pink is. So pink 27. Yes, Ayushi, I meant to do this one for you a long time ago. This one, yeah, we do just need to, it's giving us a formula. So what I'm gonna do is I'm gonna make this question a little bit more interesting. So I'm gonna say if the integral from 2 to x of f of t dt is equal to 5x over the square root of 9x squared plus 10. And then I'm going to subtract 1. And I ask you about the integral from 2 to negative infinity of f of t dt. Supposing, well, I didn't give any disclaimers in the question, but just supposing everything that would need to be true is going to be true for this. What I'm going to do is I'm just going to take the limit of this expression. Because really it's like what we do is we take the x and we let it go there. So what we're going to do is take x and let it go towards negative infinity on this fraction, 5x over the square root of 9x squared plus 10, and then I'm going to subtract 1. Okay, and this one, I haven't talked about this one probably since about August, but this limit this is the type of, that fraction here, it has two horizontal asymptotes. As x approaches infinity, it's going to approach 5 over the square root of 9 because the powers are pretty close to the same. But as x approaches negative infinity, the numerator is going to be negative and the denominator is going to be positive because that is the positive square root. So I'm going to have negative 5 over the square root of 9, and that's going to equal negative 5 thirds minus 1 is going to equal negative 8 thirds, not 2 thirds. Okay, and so that was a way I could spice that problem up a little bit, but you're just going to take the limit of the expression. I imagine, I know Ian had chimed in with that, and I do appreciate that. Let's see. I can do some alternating series, conditional and absolute. Yeah, you know what? I think I'm going to actually start with what Veer said because I was thinking, I was talking to our AB teacher on Friday, and he was saying, he was like, I'm going to be polar, right? Because he's reviewing some kids for the BC exam that are in his AB class. And I was like, yeah, probably. I was like, but we were saying polar last year, and look at what it was. It was a really easy parametric. He was like, well, what if it was like a parametric, but they asked them to find the second derivative of y with respect to x on the free response? I was like, now that would be a good one. I would like that a little bit better because the one last year was just like, there was no real excitement to it. I mean, the kids in my class were glad it was easy. I was concerned because our scores ended up fine, but I always worry when the kids report it's easy. Let me see if I can just scroll back and find one of these. I would not be the least bit surprised if I could find one in this exam. Ooh, that limit was a good one. Worked that one on Friday, though. There's a lot of McLaurin on this one. There's an Euler method. Okay, now we're going back. We're to the power rule part of the test. I kind of forgot what I was looking for also. When I see it. Oh, like let me go back to Katie's question. Base of a solid is the region bounded by the x-axis in the graph of this y equals square root of 1 minus x squared. This is a type of equation we do need to be able to recognize. That's the equation of part of a circle. It's going to be the upper half of the circle with radius 1 centered at the origin. Okay, that's as good as I've got. And that's my attempt at that circle with radius 1. Cross sections taken perpendicular to the y-axis. No, x-axis for sure. Yeah, is a square. What's the volume? All right, so that's going to be the base of my square. Remember that the area of a square is base squared. I need to, go off to the side and be like, all right, base is going to be top minus bottom. Top, I've got my y-coordinate of my top is y equals the square root of 1 minus x squared. The y-coordinate of the bottom is going to be 0. So base is equal to top minus bottom. And so if I do base squared, that's just going to be 1 minus x squared. And so area equals 1 minus x squared. And then when I go to do my volume, volume here is going to equal the integral of my area formula. And since my cross sections are taken perpendicular to the x-axis, it will be dx. And I can see from the figure that x is going to run from -1 to 1. This is going to be the integral from -1 to 1 of 1 minus x squared. And then that would be x minus 1/3 x cubed. And then that would be 1 minus 1/3. When I plug in x equals 1, I'm just going to call that 2/3. And then when I plug in -1, I'm going to have -1 plus 1/3. What's that be? No, wait. -1 minus 1/3 times -1. Yeah, -1 plus 1/3 is -2/3. And that will equal 4/3. And derivative of inverse function, I wanted to find that also. I don't even remember what Veer said. Look. Lost track of Veer. Oh, yeah, no, it was right there. Second derivative of y with respect to x both times. Okay, I'm gonna go to a different place for searching for that. It's not even the right Google Drive. This is not gonna be from a practice exam, but I am just gonna take from, let's see, let me just take from this year's unit test. Let's be in N2. Oh, yeah, okay, this one's good. All right, this is from the Unit 10 test from my class this year. The position of a car moving along a flat surface at time t is modeled by the parametric equations x equals log of t plus 1 and y equals t squared minus 8t plus 7 for t between 0 and 10. Okay, we want to find the second derivative, or it actually asks, is the path of the car concave up or concave down at time t equals 3? Okay, so we're going to check the sign of the second derivative of y with respect to x, and remember that's the derivative of dy dx. And then we won't forget to divide by dx dt. Okay, so I need to find all this stuff. So y prime is going to be 2t minus 8. X prime is going to be 1 over t minus 1. dy dx is y prime over x prime, so that's going to be 2t minus 8 divided by 1 over t minus 1, so it's like multiplying by t minus 1. I think it would be useful for me to multiply this out. 2t squared minus 2 and 8 is minus 10t plus 8. Okay, so to actually use that formula now, I'm going to take the derivative of dy dx, 4t minus 10, and divide by dx dt, which I'm realizing is still 1 over t minus 1. So if I divide by dx dt, that's like multiplying by t minus 1. And then, okay, so that's my formula. And at t equals 3 was what they asked for. That's going to be 12 minus 10 is 2, 3 minus 1 is also 2, is greater than 0. That would be concave up. And Veer, there you go. There's an example of second derivative of y with respect to x. I think absolute and conditional convergence is, that one is like really like on my mind. Integration by parts I know is on the list. Rate in, rate out, vertical axis washer problem, logistic differential equation. Eshel, let me. Oh, hello, Sam. If you've got, as you can see, I've got a long list of calculus type questions that you might not be interested in. I I forgot to try to sell the other two pre-cal teachers on doing this. But we're doing some math here. And if you have any specific pre-cal questions, do not be afraid to ask them. I might jump you to the front of the line. All of this stuff is good. Absolute conditional, I think, is what I want to do next. Then rate in, rate out, then the washer around the vertical axis, then an integration by parts, and then lastly, logistic differential equations. Not that that's necessarily, I don't know what these animals are or where you're finding them from, but you got me with at least one of those. I won't say which one it was that you got me with, but it was the alligator one. I'm gonna take a break. Give me 2 or 3 minutes. I'll be back at 9:35. Oh, how am I on battery? I'm great on battery. All right. Haley, I would say I would describe this as AP Calculus in general. I have been doing, like I teach BC only this year. I have taught AB in the past, but BC is 60% AB, so we're doing a lot of regular integration and AB stuff. But if you have any particular AB questions, feel free to ask them. I went looking for the cat, couldn't find him, but I did find some chocolate milk. So I'm gonna go for absolute and conditional convergence. And also, I think I was definitely supposed to ask for this sooner, but if this has been helpful, you should like the stream. Evidently, that is something I'm supposed to be asking you to do, is to like the stream. Evidently, it helps. I'm slightly skeptical. Direct comparison testing question. Let me think of one that would go really well for direct comparison because that's Timothy is his name. And so the sum of okay, one that I just it always comes to mind for direct comparison. I've seen this like on multiple choice, like not for a while, not any of the recent ones, but something like this: the sum of sine n over n to the three. This is weird, but if you think about sine of n, it's always between -1 and 1. So, and I know that the sum of 1 over n cubed converges by the p-series test. So I'm going to start with that. 3, which is greater than 1. And that's great, but what I need to show is that the absolute value of sine n is less than 1. So that gives me that absolute value of sine n over n cubed is less than 1 over n cubed. I guess I should say that. When n's an integer, that is going to be like a proper equality, but we're not going to get into that because we can just show this, and then therefore sum from 1 to infinity, absolute value of sine n, all divided by n cubed, also converges. That's a direct comparison. That's probably the rarest of the tests, maybe even more so than integral test. I'm gonna go. I'm hearing some. I think my TV's on or something. All right, so I'm trying to remember the one that I did in class that was absolute conditional convergence. It was related. Yeah, UDV. Yeah, yeah, that one's on my list. Integration by parts. That one's going to be right before the logistic differential equation. I like that suggestion. 81 and 23 on green. Okay, probably come after. It's like kind of specific. Seems like kind of free response-ish type questions that we've got. So absolute conditional. I'm gonna go. Oh, I know which one it was. Okay, so it's related to a practice exam. Ooh. It was that when I just, for one day only, like we did, that's close, but not exactly it. I'm gonna spend too much time looking for it, but if I see it, it'll send me back in the right direction for showing that something's conditionally convergent. I'm getting farther from what I'm looking for. And this one, somewhere makes me scroll through all sorts of stuff. Yeah, okay. So, we're going to be interested. This one is the sum as n runs from 1 to infinity of -1 to the n plus 1 x minus 2 to the n divided by four to the n to the p. And they're kind of giving us different values of x and p and asking us to, make some determinations. Okay, this one is going to be like, and this my message on this absolute versus conditional convergence is that conditional convergence is kind of like painstaking to show. And okay, I'll make note of that because I was gonna do 11 on Saturday for integration by parts. All right, I'm gonna show you that I think that conditional convergence is really best in multiple choice no calculator. So I'm gonna do two different things. If x equals 6, yeah, and p equals 1/3, does the series converge, conditionally converge absolutely, or diverge? Justify your answer. So what we're going to do, we're going to start off, just plugging in our given information. So we're adding up -1 to the n plus 1. 6 minus 2 is 4 to the n over 4 to the n. Those will cancel. I'll have n to the 1/3. That's the cube root of n. Okay, I'm looking at this, and this is exactly what I'm talking about. I show students in my class this exact series. I ask them what's it going to do. Most of them are confidently telling me that converges conditionally. Okay, and that's great. Actually showing it to be converging conditionally, that can be a different story. So what I'm going to do is start by checking for absolute convergence first. That's what I'm going to do. First, I'm going to be taking the sum of the absolute value of the terms. So I don't think that we need to show that we're putting absolute value bars around the original and getting this. I'm just going to actually take away the alternating part. This thing diverges by p-series test. P equals 1/3, and that is not greater than 1, so less than or equal to 1. Okay, and then, but then I'm going to need to show that the original series is converging by the alternating series test. So that's whoever had asked for the alternating series test, here it is. I'm going to be using the sentence, but you could do a three-step process. Is it alternating? Are the terms decreasing in size? Is their limit 0? If that's, more to your liking, that's an option. But I'm going to say it alternates. I'm just going to write it. Actually, I guess that's a sentence if you consider that first thing the subject. This thing alternates with terms that decrease in magnitude to 0, therefore it converges. That's the alternating series test. So if the series converges by the alternating series test, but if I, checked for absolute convergence and that failed, it's not absolutely convergent, but it converges, that means it's conditionally convergent. Okay, I would contrast that with like maybe part B. If x equals 6 and p equals positive, like, or 3, like 3 over 1 instead of 1 over 3, that one's going to converge absolutely. So let's just switch to red and say, all right, I'm taking the sum from 1 to infinity of negative 1 to the n plus 1. Again, the 6 minus 2 is a 4 to the n. Those cancel, and that's n cubed. Okay, what I'm just going to do is I'm going to take away the alternating part, take the absolute value of the terms. This thing converges by the p-series test. Still on there, p equals 3, which is greater than 1. Okay, so that means that my series is absolutely convergent, and that was much quicker. So that's kind of absolute versus conditional convergence. Yeah, yes, that is exactly what it means to be conditional conversion. It's converging basically only because the conditions for convergence on the alternating series test is significantly weaker than the rest of the tests. So that's what conditional convergence is. It also means that the value that the sum converges to is conditioned on the ordering of the terms, which is a much headier concept that we definitely don't need to get into right here. But there's, like a whole world of that stuff to look at. But I'm not sure who is really all that interested in it, but I know somebody out there mathematically is. Okay, that was absolute conditional. Rate in, rate out. I am going to do. I thought I'd seen one that had no calculator allowed. I really liked that. Okay, I'm thinking of one, but that one's definitely secure. Let me see. I've got an idea. I think there might have been a rate in, rate out on one of the review homeworks. So that would be most likely in C. Water is pumped into a tank. Water is removed from a tank. That is rate in, rate out. I'm going to just... Okay. Oh, I'm just going to click through... That one started out like it was going to be... There's grass clippings. No, that was just a straight rate. 4, 5, nope. Okay, I'm going to just look a little bit more temperature in the tub. Parametric. Nice polar, but no, okay. So the best I've got is from homework 1C. Water is pumped into a tank. So number 1. Okay, water is pumped in, so rate N is going to be W of T equals 2,000 e to the negative t squared over 20. This is the rate in, rate out. Liters per hour for t between 0 and 8. Water is removed from the tank. R of t, where I'm going to have to just copy in the table. And these are both in liters per hour. Okay, 0.1368. And then the values are 1340, 1190, 950, 740, and 700. All right. First, we're going to estimate R prime of 2. And these are both in, liters per hour. where the number of hours is running from 0 to 8. R is differentiable and decreasing. This is from a released exam or from a Form O of some year. I can even look and see number 1. Just click on the legend real quick. This is from 2016 BC Form O, I think. I'm pretty sure. Okay, then. All right, so differentiable and decreasing. I'm gonna say. Oh wait. Part A is estimate the value of r prime of 2. Yeah, losing track. Here it is, okay. Oh, right. At time t equals 0, there are 50,000 liters of water in the tank. I'll need that later, but not yet. R prime of 2. Indicate units of measure, show the work that leads my answer. Okay, so I'm going to say R prime of 2 is going to be approximated by, okay, 1 to 3. That's the information I've got surrounding t equals 2. So I'm going to do 950 r of 3 minus r of 1, 1190 divided by 3 minus 1. And the units will be the units of r, liters per hour, divided by the units of t, which is hours, liters per hour per hour. That's showing the work that leads to my answer. That is my answer, and they're units of measure. We didn't have to interpret, so I'm not going to. In part B, use a left Riemann sum with the 4 subintervals indicated by the data in the table to estimate the total amount of water removed during the 8 hours. Is it an underestimate or an overestimate? Give a reason for your answer. Okay, left Riemann sum for total water out. Okay, so what we're saying when we want total water out, that's going to be the integral from 0 to 8, yes, of r of t dt, and that's something that we're going to approximate using that left Riemann sum. So we're going to do, it's width times height. The first width is 0 to 1, is a width of 1. Height I get from the left edge of that interval is 1340. The second subinterval goes from 1 to 3. That is a width of 2. I use the left representative for the height, so that's 1190. 3 to 6 is a width of 3. I use the left representative for my height. And then 6 to 8 is a width of 2, and I use the left representative. That's 740. And I'm not going to simplify my answer unless I need to later. Converting an integral to the series limit of the Riemann sum, I have not, but I think what I would say, and I have to do a little bit of this because I got to prioritize. That is not the biggest deal in AP Calculus. But if anybody is like scared or worried about any of those problems where it's like which of these integrals is equivalent to like this really kind of scary looking I thinking this scary looking expression, I would recommend that you go to that web page and look at I've got videos and a worksheet on that. It's a really good worksheet. I haven't done any. I don't think I'm going to do any on this particular event, but that website would be good. All right, so that's the left Riemann sum. I need to determine if it's an overestimate or an underestimate. I'm just not on that page anymore. Yeah, overestimate or an underestimate. Well, this can't be my reason, but I'm doing a left Riemann sum on a decreasing function, so the left edge of my rectangles are going to be touching. So yeah, and I was using the bigger number of the two, so it's going to be an overestimate. Okay, I'm going to say overestimate. because R is decreasing and we used a right Riemann sum. Now, they always use, I think overestimate because R is decreasing gets the job done. I don't like this language. We used a right Riemann sum, or no, we used a left Riemann sum. But I'm going to say that just in case. Use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. All right. I'm going to just write an expression and not evaluate it because I don't really want to. At t equals 8. Okay, so we're starting off with 50,000 liters of, that's 5,000, 50,000, and then we're going to add the integral from 0 to 8 of rate n to get the total n, which is what we just approximated. And then we'll subtract the integral from 0 to 8 of rate out, which was w of t. Wait a second. Was it? Oh, okay, so we did do, R was removed. Okay, that kind of makes sense. I just had the wrong idea about what was rate in and what was rate out. Okay, so it's going to be W minus R. That's fine. It's a fixable mistake. Rate in minus rate out dt. Okay, but we can't exactly do that on the calculator. So what we're going to need to do is 50,000 plus the integral from 0 to 8 of w of t dt, and we will need the dt there, minus, that's where I'm going to do 1340 plus 2 1190s plus 3 950s and 2 740s. Okay, I've got all of that ready. I would round that to the nearest one. And do we need to know about midpoint Riemann sums for AP Calculus? We do, at both AB and BC. How to integrate by completing the square. Yeah, Mr. Sewell, I think I'm gonna redirect you to something also, because this is really, let me just check something real quick. So I'm gonna bring up one of my videos. If this is a short video, I'm gonna send it on to you. If not, it's 16. Let's see. Okay, I'm gonna advance the video to like where you would need. Because I'm really of the opinion that integration by completing the square. Oh no, I want to actually start at the time I wanted to start at. I really do believe that integration by completing the square is, it's gonna be this arctangent thing, and specifically, it's gonna look like a typo. It's not factorable in the denominator, so it looks like an error. You're like, they meant to say this other thing. You know what I mean? Like, and if you look at that video, you'll see some cases. It's like off from a perfect square by exactly 1, and it would end up being arctangent of x plus 3 or arctangent of x minus 7 or something like that, when it's just off from a perfect square by exactly 1. Okay, so I am over there in my email, which is probably not a good place to be. That was part C. I am going to try to finish off part D, do my rate in, rate out. I recognize I've got some more requests coming in, and I'll kind of try to get to those in the order I get them. Is there a time t at which the rate in is the same as the rate out. This is going to be intermediate value theorem. Okay, so we want to show, this is great, okay, because I was just talking about this at the beginning of the stream, like 3 hours ago. And I'm thinking, like, at this point, I'm feeling some fatigue. I got to think other people are too. I'm going to go to 11, I think. If there's still questions, if there's still a lot of questions at 11, I might go a little bit later, but I definitely won't be going later than 11:30 because we got to get our rest, right? The things that we can control going into tomorrow are we need to show up on time. Okay, that is something we can control. We need to show up with a calculator that's in radian mode. That's something we can control. Now, if we don't have a calculator and we're struggling with that, I'm going to be there with some calculators, but not like an infinite. I don't have an infinite supply of them. If I did, I'd just give them out to everyone. We need to be showing up with food in our stomach and having rested some, right? And knowing the formulas we need to know. It might be a little late to know the formulas we need to know, but you could always shift over to working on that right now. Do that for half an hour, review the formulas, review them as you're getting up and getting that food in you, right? If you're going to review something as you're just like eating before the exam, before you leave the house, you should just review the formulas you're supposed to know and just be like, yeah, I know these, I've got this. That's what I want for you. But I do want you to eat food before, because, going all the way until noon for y'all could be like a little taxing, doing all those calculus problems, not having eaten. I do that all the time. If you're used to it, it's fine. But if you're not used to it, then you should definitely eat something. All right. We want, is W equal to R on the interval 0 to 8? Okay, well, I'm just going to do, I'm going to be doing before and after type analysis. I'll switch up the color. I haven't really done too much of that. I've just been kind of going, well, that's not a very great selection of color. Let's see what else I've got for I'll use pink. All right, is W equal to R? I'm going to let f of t equal W of t minus R of t. You could do R of t minus W of t, it doesn't matter. I'm going to say f of 0, which is W of 0 minus R of 0. I need to go back and look at kind of the information I had. W of 0 is going to be 2000. R of 0 is going to be 1340. 2000 minus 1340, which is a positive number. I'm hoping that f of 8 is a negative number. And then I'm going to say, because if it wasn't, then I'd probably have to go and check one by one on each of these, and that's less realistic. So I got to expect that it's going to be yes. All right, when t equals 8, I'm going to be having 2000 e to the negative 64 over 20. And then I'm going to be subtracting 700. Okay, this is where a calculator is going to need to be something we have. I'm going to just do this using my computer. 2000 e to the power of negative 64 over 20. Oh, I need definitely parentheses over that because it just did e to the negative 64. Give me a really small number. Okay, that's 81.5. I subtract 700. That's clearly negative. Now, if your calculator was not working, I would just go for it. Just take a risk, take a chance. Do it. Believe in yourself and believe that, it probably got to be a yes, right? And so it went from positive to negative. F is continuous. On the interval 0 to 8, because both W and R are differentiable. Remember, they told us R was differentiable and decreasing. I used the fact that it was decreasing. I hadn't used the differentiability yet. Here it is. That's why I needed it. So, yes, okay, F goes from positive to negative. F is continuous. As a result, I'm going to say yes. just probably leave it at that. Okay, so that was the rate in, rate out question. I liked that. That was good. Done that. Let's do a washer problem around a vertical axis that is not the y-axis. I don't remember who that was. That was really probably close to 3 hours ago that somebody had asked that. But it is not the most important thing for BC. I'm going to say, let's do one that we have not done much of. Yes. Let's look at R is bounded by the line x equals -1. The graph of y equals cube root x, and the lines y equals 0 and y equals 1. So it's not entirely visible to you. All right, there you go. R is going to be bounded by that. I'm going to want to set up, thank you, Finley, for all that stuff. Sliding ladder? Sure, it's been a while. But yeah, that's totally one I would do. I'll go look one of those up. I know I had one of those on my unit test this year. All right, so R is bounded by these. I want to rotate R around, let's say, and I'm just going to set this up and not evaluate it. A vertical axis that's not the y-axis. How about x equals 5? Okay, first we're going to need to produce a sketch. Okay, so here's going to be my y-axis. That will be an x-axis. Okay, remember y equals cube root of x. Kind of looks like that. Okay, I'm going to let y equals 1 be, I don't know, maybe about right here. That was a little too high. Let me just go down a little bit. That's more like it. Okay, y equals 1. Y equals 0 is the x-axis, and x equals -1. Okay, so that's going to be my region. Let me get some highlighter going here. That's entirely too thick. And there we go. Yellow region, that's what I'm rotating around the axis x equals 5. Okay, I'm going to draw this. It's not going to be totally, drawn to scale. And so this is really going to have some hollowness to it, right? It's just going to be like some kind of circular thing. It's going to be really weird shape, but it's going to have a volume. And we can figure out what the volume is. Okay, I'm going to reproduce the drawing to be a little bit more, just what we need. And then I'm going to draw the axis. And then I'm going to go for my 2 radii. I'm going to start with a large radius, and you know what, I just don't like this drawing. This is not big enough. I really want something I can really work on. So that's going to be my axis. I can work with that. The large radius reaches from the axis of rotation all the way over to the far edge of the region that I'm rotating. Okay, and I'm going to call that one A. Okay, and then the small radius reaches from the axis of rotation all the way to the near edge of the thing that we're rotating, and I'm going to call that one B. Okay, I am going to need to get coordinates for this, like right minus left, right minus left. Okay, so A is going to be right minus left. The right-hand coordinate is that vertical axis, that's x equals 5. Minus on the left, okay, that's x equals -1. Okay, so that's going to equal 6. And then for B, I need to do a right minus left. On the right, I've got x equals 5. And on the left, I've got x equals, well, I don't really know what x equals. I know y equals x cubed. No, cube root of x. I can't give that away. So x is going to equal y to the 3. So over here, the left edge of B, the x coordinate is given by y cubed. Okay, and then that's 5 minus y to the 3. That's I'm supposed to do something here. Okay, volume in a washer situation is pi times the integral of a squared minus b squared. If we're rotating around an axis that's vertical like the y-axis, it will be dy, and y is running from 0 to 1. Now, if you're like feeling really confident and you're like we're extremely explicit about what a and b equaled, and it's just a setup problem, that is probably going to earn you the credit, but I wouldn't take any chances if it was my AP exam, so I'm going to write pi integral from 0 to 1 of a squared is 6 squared minus b squared is 5 minus y cubed squared dy. And then that'll be us rotating around rotating washer around a vertical axis that's not the y-axis. Okay, integration by parts. Ian, number 11 from the Saturday exam. I'm ready. Okay, Saturday exam 2016 BC. Great choice. Love these. I grew to like these more this year. I've not forgotten about sliding ladder person. I'm going to do that one right after this, I think. Integration by parts, number 11 from Saturday. Integral from 1 to the square root of e of x to the 5 natural log x. And once again, I recognize this is slightly different from the multiple choice question, but you know, that one's a secure item and this is not. So when we see this kind of like very flat product here, it's just like x to the 5 times log x. There's no composition of functions. It's just this times that. This must be UTV. Okay, so we're thinking integration by parts. I'm going to let u equal ilate algebra and log. Ilate. Log came first. Okay, usually algebra comes first, but log before algebra. U equals log x, dv equals x to the 5 dx. Okay, but if you'd made the wrong choice and you were trying to anti-differentiate natural log, well, that wouldn't be the best thing ever, right? You don't really, I mean, you can figure it out using UDV, but it's not one that we're supposed to know off the top of our head, and it's definitely not 1 over x. That's the derivative of log. Okay, so I'm going to take the derivative of u and the antiderivative of v. Okay, and I'm going to remember that the integral of u dv equals u times v minus the integral of v du. Okay, so this is going to be equal to u times v. X to the 6 over 6 natural log x, x running from 1 to the square root of e, minus the integral from 1 to the square root of e of 1/6 v x to the 6 du is 1 over x dx. But what I can do is look at these and be like, oh, I'm going to hit that with some algebra. X to the 6 times 1 over x, that's x to the 5. Okay, so 1 over 6 x to the 5. Okay, then I'm going to anti-differentiate because I'm still doing this integral on the right. That's going to be 1/6 x to the 6. I already have a 1 over 6. That'll be 1 over 36 x to the 6 running from 1 to the square root of e. And then x to the 6 over 6 log x on the same interval. And now I'm almost ready. I'm going to need a new page. No, I can't. At least I need a whole page for this. X to the 6th is going to be e to the 3 over 6 times the natural log of the square root of e is a half. Minus, natural log of 1 is going to be 0, so I'm going to stop there. That's the first thing. Minus 1/36 of square root of e to the 6th is e to the 3 minus 1 to the 6 is 1. Okay, I recognize I made this question a little bit more complicated, but that's definitely the No, Zach, like I don't think you need any last minute words of encouragement for a three. In fact, I think you're getting three threes tomorrow at least. You got BC, you got AB. Then you're gonna get two passing scores on that, and then you're gonna eat a granola bar and sit down for pre-cal, and you're gonna get definitely gonna get a three or higher on that one. But I'm also really interested. I mean, because pre-cal is such an unknown. I'm excited for you and my multivariable calculus student to sit for the pre-cal exam, because if y'all both get three or higher, I think everyone in here that is reviewing for AP Calculus, I'm going to suggest, if you're still in high school next year, to take AP Pre-Cal exam next year. And I might just, kind of like give you a crash course in the multivariable class. If you're with me in there, I'll probably record a crash course for AP Pre-Cal for calculus students, or for former calculus students, or just people who didn't take the class, people who are in a regular class, people who just school didn't offer the course but want to take the exam. I think I see potential in that type of video next year, especially because that's going to really be my perspective. It's like very much an outsider on pre-cal. Even though I taught it this year, I still feel like an outsider. Okay, anyway, sliding ladder for related rates. I'm going to go back to my Unit 4 test from this year. Yes. I think that's just... Okay, that's a street light. Yeah, here we go. Alright, so the top of a 25-foot ladder... That's the ladder. Is sliding down a vertical wall. So the ladder is 25 feet. At a constant rate of 3 feet per minute. Now, yeah, my names for this are going to be X, Y, and R. dy dt is -3. And I'm reading to you from a multiple choice question I gave in the past. But the top of a 25-foot ladder is sliding down a vertical wall at a constant rate of 3 feet per minute. When the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? So dx dt equals what? Okay, now we've got everything we need, okay, because the one thing that we know in this situation, ladders and everything aside, is that we're working on a right triangle. So what I know for sure is that x squared plus y squared is equal to r squared at all times, because this is a right triangle. So what I'm going to do is take the derivative of both sides of this equation in red with respect to time. And so I'd get 2x dx dt plus 2y dy dt, and that'll equal 2r dr dt. And that's great. I'm going to just plug in everything and hope for the best. Okay, I don't know what the value of x is yet. Maybe you do. But dx dt is what I'm hoping to solve for eventually, but I'm going to do some work to find x before I kind of go for it. 2y is going to be 14, dy dt is -3, and that's equal to 2r, which is going to be 50 dr dt. And think about it. How much is the value of r changing if the ladder is sliding down the wall? It's not like the ladder is getting longer or shorter. So I'm going to say dr dt is 0. And that's really helpful. Okay, I do need to know the value of x though. Now I'm going to go off to the side and say, okay, either you know your Pythagorean triples and you know that it's 7, 24, 25, just like in your heart or something. But if not, you're going to say 7 squared plus x squared equals 25 squared. 625 minus 49 is going to be like 576, which is going to be 24 times 24. Is that true? Yep, sure enough. I know my Pythagorean triples, so I don't have to worry about, difficult arithmetic and stuff like that. I do also think I allowed a calculator on this one. And okay, okay, great. I'm able to just go ahead and I'm trying to knock something else out while I'm doing this over here. Let's see. Oh, no, 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 no. The number of people that are trying to argue with me on my full practice exam about the decreasing in the rates and stuff is like, I think at this point, I'm just going to be hiding user from channel. I hate to do that. The, yeah, yeah, that's that, but I'm not going to be getting into that when they're just factually wrong. Root of 1 plus the derivative 1 plus the derivative squared. Oh man, those are going to be those are going to be tough, as you know. Oh, Elliot, man, let me just tell you, I'm teaching this AP pre-calc class, and they are having us reason with all these rates of change and talk about where functions are concave up and concave down, which is just like the students in my class reacted surprisingly well to it. But people on the internet, they think that something that's decreasing in concave up is decreasing at a decreasing rate, and they are like certain of it. And oh, man, and it's really hard because it's like they don't even know about the derivative yet. So like, it's going to be tough for me to, you know, really be harsh with them. But like that one took a wrong tone. Also, saying you got number one wrong. Like I don't know you, and you're not as good as you think you are. Okay, 724.25. 48 times the thing I'm hoping to solve minus 14 times 3, I think is going to be 42. That's going to equal 0, so 48x prime equals 42. X prime equals 42 over 48, which we could definitely simplify by dividing everything by 6. That's going to be, I think, 7/8. 6 times 7, 6 times 8. There we go. And what was I going to say about this one? Oh, check my answer for reasonableness. If the ladder is sliding down, the bottom of the ladder is going away from the wall. So I would expect x to be increasing. I would expect it to have a positive rate of change. Elliot, I'm just glad to see you in here. Oh, I thought you were telling me to integrate the root of 1 plus the derivative squared. At first, I was thinking the square root of 1 plus x squared, and I was like, oh man, that could have a trig substitution. That's exactly what I was trying to avoid tonight. The arc length formula at Hudson, yeah, Elliot just chimed in with it. Elliot's a strong mathematician. So I think would be the shortest way to say that. I hit the integration by just completing the square. Ian, thank you. I've really enjoyed the journey with you. You know, you know how I feel. So I'm gonna leave it at that. Let's see. I kind of feel bad. Should have, but I'd already addressed that exact accusation on number one or elsewhere in the comments. This is a good one. Okay. I'm working down my list. I don't think I need that that tab anymore. Over here, I've kind of lost track of what I'm doing over here. I've hit that. thought I was going to squeeze something in between. Oh, yeah, that was the sliding ladder related rate. Logistic differential equation. Then I've got a couple of requests from Green. Can definitely do that. You know, I'm just gonna once again remind you that that evidently I should be asking you to like this stream if you like this stream. So like if you're enjoying it, you should definitely give me a like. I usually don't ask for that for those types of material things, but I am now. Okay, I see somebody hooked me up with one. Very appreciated. And I don't know exactly how. But it will be interesting to look at revenue data. What I did notice on a YouTube data level, this is, oh, glad to hear that, Hudson. What I noticed that's super interesting that like, oh man, if I only just had like a little bit more time or a little bit more watch data or something, is that like, the past couple of days, obviously I've been taking more views, right? And the more views you take, the closer your data gets to sinusoidal, like on a day-to-day basis. Like it was the curves were so smooth. Yeah, I the thing about number two on the Saturday free response is that one you have to use a calculator. Appreciate you, Hudson. You have to use a calculator, and I do have the scoring, like the scoring guidelines. I've got the full work on them. I'd prefer to not do that one. I'm going to try to knock out the logistic differential equation question and the green 81 and 23 first. And then if there's still time and we're still wanting, then I'll just go through and do that whole homemade polar question that I made up somewhere along the way. The, okay. I, yeah, I'm out of milk, out of water. My throat is getting dry. I'm going to take 1 or 2 minutes to get more liquid, and then I will be back shortly. I'm going to check the battery situation. Definitely going to roll an ad on y'all, I think. Yeah, let's just go ahead on enable monetization. Oh, this thing had better be monetized. I'm a total fool if it's not. I don't even know how you do that. Let's see, where even are the settings? I don't want to spend too much time live on the settings, but no, yeah, don't worry. It's on. I know you weren't worried. I was. All right, be back, man. Probably 2 minutes. Maybe I'll bring a cat. All right. Here we go. Cat that's not terribly excited. Yeah, see here. Yes, he is struggling. He is going wild. We're going to enlarge the window so you can see his wildness. See, this is a wild cat here. Yes. Yes, here he is. Calculus cat. Okay, so. Oh, unironically invested. You know, I'm glad to hear that. It worked for you last year, Will. I think I not gonna like go in and review my data, but I like to think that that we made some progress in the final push with you last year, Will, and I think there's other people making some big progress in the final push as well. Okay, and now he's doing his own thing, which is what he prefers to do, I think. AQTs, I think you're going to be all right. Keep in mind that the cut score for a 3 on AP Calculus is not 70%. And I don't know where you're from, but in our great state, they passed a law that if you get 3 or higher and you go to a public school in the state, they have to give you the credit. Now, yeah, whoever you are. Okay. Have you heard that yet? Now he's telling me about it. Actually, he's got his friend down here. He's got this toy that he talks to. It's a strange thing. All right, so I'm gonna jump in. I'm gonna do green 81 and 23. Now, I have to admit, okay, green should be. I think it's gonna be this one. Let's look and see. Okay, I believe that was Annika that requested those. If you could tell me, were you asking for, oh, kind of an oval shaped region, volume of a solid cross section? Is the mustache required for a 5 on the BC? In fact, I would say it's not. I did not have it when I took it. I didn't get a 5 either, though. So I got a 4 and I had no mustache. Maybe that, I don't know. But I know, like, a good proportion of my students, that's not really an option. So I don't think that's required. Okay. Oh, wow. There's been some chat while I was gone. Free response, pen or pencil, whatever. It's a scan. Yeah, you do whatever you feel best with bread. Let's see. Yeah, if it's an integration parts, no, I would. So Hudson, I'm thinking I late. If it's integration by parts and it's x e to the x, I late. Inverse trig, log, algebra, regular trig, and exponential. U is whatever comes first in that acronym. So if I've got exponential and algebra, algebra comes first, and I want U equals x. Okay. Annika, I am pretty sure that the 81, that makes a lot of sense that you would ask about that one. It kind of looks like an oval. I'm going to decline that one. You don't need to worry about that. That one was really out there. I really didn't like that. This other one, on the other hand, this is exactly what we need. Okay, so I'm going to change it up a little bit, but not that much. You'll see how it's not that different. Integral from 5 to x cubed of the cube root of t dt. And so we're going to say, I'm not even going to make this a multiple choice question. We're just going to ask, what is f prime of x equal to? Okay, so remember that f is actually a composition of functions. First, there's the integral of, cube root of t dt, and then there's also x cubed. So what we're going to need to do is throw that x cubed in wherever we see t in the integrand. That's this thing. And so f prime is going to equal the cube root of x cubed multiplied by the derivative of the inside for the chain rule. So times 3x squared, multiplying that times the cube root of x cubed, which is going to be x. That's going to be 3 x cubed. All right. And so that's how we would do that one. I think from there you would be able to see what the correct answer is going to be for your equivalent problem. And okay. I did those. There was something else that, oh, there was like kind of like some miscellaneous free responses that I just kind of, from the various colors. If anybody's still in here and wants me to hit free responses, I'm obviously going to do number 2 from the Saturday exam because that was requested more than once. I've got that one. I'm going to just quickly, actually, that might already be in here. Polar. I think I did not do a very good job of this year of like keeping my files straight. It's kind of chaotic. But I know I emailed it, and I know who I did email it to. Okay, the homemade polar free response. All right, just download that one. Drop that in. Maybe was it under H? Homemade? No. One second, I'm gonna just probably write directly on that. So I'm gonna bring that on, cover my screen while I go grab this. Calculus exam review. Where are you? Homemade polar free response question. There we are. And then going to be, how do you mark that up again? Oh, yeah, hit that. And now I'm pretty much, yeah, my toolbars are partially showing, but it's going to be all right. That's not the type of pen I need. Find the value of theta that corresponds to the point on the graph of r equals f of theta in the first quadrant with y coordinate equaling 2, right? Yeah. Show the work that leads to your answer. All right. So if we want y to equal 2, what we're really going to need is r sine theta to equal 2. That's a formula we need to know. Y equals r sine theta. In this situation, r equals f of theta. So that's 1 plus theta sine theta equals 2. Yes. Okay. Commentary from back there. And all right, so and this is an equation I'm going to need to use the calculator to solve. And one moment, please. I get a Desmos window going. I thought I had, oh, that's a different machine. Seriously, I think by now you would know this machine pretty much on the internet only ever goes to Google Drive and Desmos, but all good. Let's just get rid of that stuff. Let's see how that looks. Good enough. All right, so I'm going to go in here and I'm trying to solve the equation 1 plus theta sine theta. So 1 plus x sine x. And I'm interested in where that equals 2 in the first quadrant. Maybe I should say y equals 2. Okay, in the first quadrant, that's going to be between x equals 0 and x equals a half. And this is the same thing you would need to do on a calculator. You must be doing this, yeah. I'm not sure. That's an integral that you could probably type into Wolfram Alpha and it would give you an exact answer and you could check yourself quicker than I could check it. I will do that integral here in a few minutes. But you need to solve this equation in function mode. I have to admit, I have not exactly been exactly the type of teacher I want to be about this. I've been a little short with people. I've told people like that have asked me in the past week or so, like, how do you find the intersection of the two polar curves? I've been saying like exactly the same way we've done it the whole time. I'm a little concerned when I take that question this late in the game, though, because that means you just watched me, or even like probably just skimmed through on the video of me doing it and just copied down the answer and not learned for yourself. And that's very frustrating, right? Obviously for me, and I'm frustrated for you that you've just like kind of wasted all this time, done all these examples, not learned anything. Okay, so we have to graph in rectangular mode. Polar mode does not have an intersection capability, and yeah, for good reason. You don't want to go into the world of polar intersections. I one time got trapped in that when I used to do math tutoring, and like I said, you don't want to go there. It can be really nasty. We need more than 1.171. I need more decimals than that. That's one weakness with Desmos that I'm really not sure how you're supposed to solve this equation and get more precision besides like really zooming in and stuff. I'm just going to go with 1.171 and hope for the best. But I would not. Oh, actually, no, I'm fine. I'm fine. I've got the answers right back here. So I'm going to go. Oh, no. Yeah, that was the answer. This was not the intersection. This was an intersection, but not the one that I need later. Theta equals 1.171. I'm good. And I can, that's probably what y'all are seeing now. Yeah, okay. You saw me do that. Okay. Now, moving on to B. Find the area of the shaded regions. Show the setup for my calculations. That is going to require me to find the intersection here. Okay, and so that's where f of theta equals g of theta. I do need to go back to Desmos and let's see. Okay, that's an option. And I'm going to go back to Desmos here, and I'm going to kind of get rid of the sine x. 1 plus x equals, I hear you, dude. It's really got a lot to say here. Theta to the 3 over 4 is the other term. So y equals x to the power of 3 all divided by 4. Okay, and I'm going to see that they intersect over here, which is at the point 2.383. Okay, in reality, I know that this is, okay, I'm going to say f of theta equals g of theta. That's the work I'm doing here. That's the equation that I solved with the calculator. I think it's important that I remind you that anytime we solve an equation with the calculator, we have to write the equation that we solved. It doesn't have to be complicated. I wrote f and g intersect at, that's going to be equivalent to f equals g. Theta equals 2.382978. That's an advantage of the TID4, but I got to think that by the time we need Desmos for the AP Calculus exam, which you won't if you're watching this right now, by the time we need it, we'll be solving with more accuracy or more precision than 3 decimals, because we need all the decimals to make sure we're not wrong in the last decimal. Okay, maybe I should have left him upstairs to do his own thing, because he's just really telling me about it. Okay, so, oh yeah, and then also I need to explain why I'm going to be adding my areas here. Okay, so think about how polar area works, right? It's an area scanner, and it works counterclockwise just like the unit circle. So I'm going to go and I'm going to be adding these pieces of pizza all the way until I get to the intersection point. And on these pieces of pizza, I'm adding on the curve that starts at 0, so that's g of theta. Okay, now you had a calculator, so you could probably figure out which one's which, but I'm saying you don't need to go into polar mode. So this is g that I'm integrating on until the intersection point. So that's from theta equals 0 up to theta equals whatever. And then after that intersection point, I'm going to switch over to curve f, and I'm going to be adding that area, adding these pieces of pizza. Here. All right, so going back to my integral, the first one is going to be g of theta squared. Okay, so 1/2 of the integral of, wait, it was blue first, was g of theta. Remember, polar area, 1/2 r squared d theta. And then theta is going to run from 0 up to that nice intersection point of 2.382 dot dot dot. And then I'm going to add another area, so that'll be 1/2 of an integral. Theta is going to start at 2.382 dot 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 going up to pi. I'll probably just write that in black though. 1/2 r squared. The second r I had written in green was f of theta. It's the integral of 1/2 r squared d theta. That's the setup for my computation or my calculations. You don't need to see me type this into an integral though. I think that will be enough. Okay. Now, after that, I'm going to move on to part C. And now this is a little something else. These are just a couple of parts that are similar to some other problems I know. G is theta to the 3/4. I'm just going to copy that. Equals theta to the 3 all divided by 4. All right. Curve moves, or an object moves along the curve r equals g of theta in such a way that theta increases 0.53 per second. So d theta dt is 0.53. At the time when theta equals 2, what's the rate of change in the distance between the origin and the object? Okay, rate of change in the distance between the origin and the object, that's dr dt. Okay, so I might say over here, they're asking me to find the value of dr dt at the time when theta equals 2. So I'm going to need to take the derivative of both sides of this equation with respect to time. So the derivative of r with respect to time, and I'm going to take the derivative of theta to the 3/4. That's 3/4 theta squared. But theta has its own derivative with respect to time. They just told us that. So that's times d theta dt. Okay, so I'm just going to plug in 3/4 theta equals 2. I'm going to square it, and d theta dt is 0.53. And then, hey, what's up, Prakar? I would say it's a little late for you, but who cares? I know you don't have an AP exam tomorrow, because I know you're not taking calculus or pre-cal, so you do what you're going to do. You were another person who was in here last year and who really, I think, benefited from it. You made a really big push in the last couple of weeks and achieved a score on the AP exam that I previously thought, you wouldn't. And for anybody in here right now that has been like quiet in the chat, or I don't even realize is there, but has is borderline 2-3, people last year gave me a lot of hope for y'all, because I had a lot of surprises last year in the positive direction. I did also have a few surprises in the negative direction, but it was kind of like people I expected to get a 5 got a 4, and I can live with that. I don't think I even knew what to expect. I don't really think I even knew what was going on when I was at y'all's age. Wait, no, I don't want to go back. I want to keep this. Okay, that's my answer right here. I don't have to simplify that. That'll be enough. All right, and then there's a point on the graph of r equals g of theta where the slope of the line tangent to the curve, I'll switch to green. Okay, and somebody had asked me for that a long time ago. Polar slope. And he left a while ago. I'm still going to do it, though, in case he checks back in the morning. Okay, we can do that. Okay, when they say slope of the line tangent to the curve, they mean dy dx. Okay, I could probably use a little bit more green real estate. So dy dx is equal to dy d theta divided by dx d theta. And this is not one we're going to have to use product rule and everything. Yes, Veer, you do. It's getting to be time. I'm really thinking I'm seeing the end coming here. I'm going to do a few of these. I'm going to do a polar slope for, anybody that's interested. If anybody got any particular request, yeah, good and bad, right, Prakar? I bet. Good and bad. That's the experience going through my class, I think. A lot of good, a lot of bad, a lot of everything, a lot of paperwork. Okay, so you hardly ever see me writing on paper, right? I'm always writing on the computer, but I'll let y'all do the paperwork because I was thinking about this recently. I think a lot of people in my classes, not forever, right? But are going to go to jobs where they have to deal in paperwork. And man, I feel like some of our classes could be, but are not teaching you those organizational skills you need. Okay. Oh yeah, let me do, okay, I'm going to finish this off. I'm going to do that x e to the x from 0 to 2. Then I'm going to loop back and do polar slope, and then I think I'm going to call it. All right, but anyway, dy dx is negative 6 over pi is equal to dy d theta, 3 pi squared over 16 divided by dx d theta. And the key with this one is as long as you just don't think about dx d theta as too much of a fraction, just as like the thing we're solving for, we're going to do cross multiplication, and we're going to be happy. I'm going to multiply pi over there, so that'd be 3 pi to the 3 over 16. I'm going to divide both sides by 6, or I guess negative 6, and I'm going to get negative pi cubed over 32, or negative 3 pi cubed over 96, because that would be the same thing. 16 times 6, definitely 96, yeah. Okay, and that's going to be, wait, dx dx. That's troublesome. What dx d theta there, and that's number 2. Okay, I'm glad to be helpful, and and the biggest thing in all of that message is that you're feeling confident. That's really that's the reason for me being here tonight, and not just like I don't know watching TV or whatever, or realistically already haven't gone to bed by now. But like that's the reason is I just want people to feel a little bit more confident than they would have otherwise, and supported because it seems like lately AP Calculus has been on a Monday, which 2 days of lack of support. I know y'all are strong, but sometimes you like to feel like you've got a lot of support, and so I'm going to turn that off. Go back to my original note. Going to do that quick integration by parts, which this one is going to be nice and quick compared to some of the other problems I've done. So the integral from 0 to 2 of x e to the x dx. UdV is kind of one of the things that just makes BC BC. U equals x, dV equals e to the x dx. Okay, so that means du equals dx, v equals e to the x. I am a fan, for anybody that's not in my class, oh my goodness, Elliot, you have no idea. One of my co-teachers, a rising star in the mathematics game, I also think, I don't know if she's like just going and looking for it or if it's actually a magnet for it, but she finds all of this like wrong math information on the internet. And at first I was like, what are you talking about? Like, I've never seen any like wrong math information on the internet because pretty much people just get eviscerated for wrong information, first of all. And the second of all, it's kind of like not that hard to be right for math, especially if you're like well trained. But man, the rate of change of the rate when that rate is negative. And I get why they added it to the AP Pre-Cal course because it's like a very commonly misunderstood topic in calculus. But man, yeah, I know exactly. It's the norm of the slope, and and I had a comment that was like actually pretty coherent. It was like it's slowing down. I was like, yes, it is. But the question didn't ask if the rate was speeding up or slowing down. It asked if it was increasing or decreasing, and it really goes back to like the good mathematics stuff. Our definition of increase decrease has to do with greater and less. And people, but they're really defensive about that. And if I continue to teach pre-cal, I would, and there a little bit of it in my class, but I usually just, yeah. Yeah, that's the graphics on Google Images, right? Yeah, that's where Miss Salas is getting all of these wrong math things from, is Google Images, and she'll just like pull out a Chromebook and like just stick it in my, like, look at this. Like, can you believe that they're doing this? And now I can, because I see, and then I'm afraid, especially when I don't know them, that they may have been instructed wrong. And I could understand that too, because I was sat in Summer Institute with people that had never taught pre-cal, and they were about to have to teach AP pre-cal. I mean, I only taught pre-cal once, but at least I taught the calculus class a bunch of times, and so I knew like what they needed. Anyway, integral of u dv equals u times v minus the integral of v du. But how do you fight against misinformation in mathematics? I mean, it's hard enough in with other things. but it's whack-a-mole, right? And I think the people in the journalism industry have the same issue. But I am not an expert on that. Although I am a little bit more of an expert on journalism than I used to be because I'm going to the state meet in journalism on Tuesday. For anybody that cares about that, I definitely wasn't good enough to go to the state meet in anything when I was a kid. But I've got a journalist, and I became the default journalism coach this year. And so I'm getting propelled to new heights as a teacher. So this is going to equal x e to the x from 0 to 2 minus the integral from 0 to 2 of e to the x dx. And this is going to end up being pretty nice. So this is 2 e to the 2 minus 0 e to the 0. And then I'm going to subtract, right, e to the x from 0 to 2. And so as long as I keep my parentheses straight, I should be fine here. Minus e to the 2 minus e to the 0. All right, so minus a negative 1, 2 e to the 2 minus an e to the 2 is going to be 1 e to the 2 plus 1. Okay, that's interesting. Alternating series error. Convergence of series and such if not already done so. Okay, Anthony, I'm going to send you back to look. I did calculate the 2023 BC number 6, and there was Lagrange error on that. It went, actually, I can probably find it. I can tell you where to look for Lagrange error because I'm not going to do any more of those because what I said, I promise, is enough. Let's see. That was a bunch of theorem talk, improper integration, infinity, where to put it and where to not. There's a trapezoid sum. Here it is. All right. You want to go back about 2 hours and 35 minutes is what it looks like to me. Let me skip ahead to live. It won't actually tell me what the actual timestamp is, but if you go backwards 2 hours, well, if you want just Lagrange error bound, then you'll go back 2 hours and 31 minutes, 11 seconds. Go back about 2.5 hours, and you'll see it's all of this work with, it starts with f of 0 equals 2, f prime of 0 equals 3. That's 2023 BC6. It's got a really nice Lagrange error part in the middle of it. Alternating series error, I'm going to do 2022 because it was there and because it's been requested. There was one other thing that I mentioned I was going to do. Okay, so I said I was going to do that integration by parts. I can go back to chat. Did the integration by parts. No, there was something. Oh, Polish slope. Limit comparison test. Yes, Presley, you've been waiting for too long for limit comparison test. All right. Let me give you like a super standard one, and then like something that's like really out there, and I think that should probably cover it, right? The standard, the extreme. Let's just do limit comparison test. This is a test for convergence, Anthony. I've done no limit comparison. Okay, limit comparison is where we know one, we've got one in mind. Oh, it's supposed to be a square. We've got one in mind. It's pretty close to the one that we're interested in, and we're gonna. Ooh, Sam. We're in gym 3. I think you go into the round gym doors to get to gym 3. I'm gonna be gym 3. Wait, that I don't even know what gym 3 is because I'm thinking of the Ox gym. Anybody got anybody taking an exam in gym 3 this year? I know it's gym 3. I envision Ox gym, but I don't think they're using that one for AP exams anymore. It's the PE gym. Okay, I do know about that one. It's been a while. I used that office for a while last spring. Go to the door near the gate. I'll be there. If it makes anybody feel it's in the link hallway. That's what I'm talking about. Yes, yes, yes. Go in the link doors. Yes, I remember this now. It's all coming back. But yeah, the it is the gem attached to the link, kind of, whatever. That whole area, not the most familiar with it. I'm trying to remember why I was using that office in that PE gym last year in the spring. I don't know if I did like a practice exam in there or something. Anyway, limit comparison. All right, so example one. This is the most standard is like polynomial on top, polynomial on bottom. So the sum as n runs from 1 to infinity of n to the 3 plus 4n divided by 5n to the 4 plus 99n to the 3, or something like that, where it's like, oh, they want you to think it's like, oh, it's way bigger on bottom. But in reality, it's only bigger on bottom by 1 power. So what I'm going to do is I'm going to limit compare to the harmonic. So I'm going to say n equals 1 to infinity of 1 over n, because that's really what I've got, is a series that's bigger on bottom by 1 power, diverges because it's the harmonic series. Okay, now I'm going to do my limit comparison. So I'm going to do the limit of the ratio. So I've got n to the 3 plus 4n over 5n to the 4 plus 99n to the 3 multiplied by n over 1 divided by the terms of the harmonic. And that limit is going to come back, okay, n to the 4th over 5n to the 4th, that's going to be a limit of 1/5. Because this is positive and finite, I can conclude that my series here, sum from n equals 1 to infinity of n to the 3rd plus 4n divided by 5n to the 4 plus 99n to the 3, also diverges. Okay, that's the most common thing. What is log x times 2x? If you're talking about integrating that, you would use ILATE again, and you would have u equal log and dv equal 2x dx. I'm not sure. Without more information, I would need more to do more. I'm going to clear this one out and then look at like an extreme limit comparison case, which I think is something like 1 over n2 to the n. I mean, you could use direct compare. Oh, that's not it. I'm trying to think of the one where you limit compared to the geometric. I'm just going to be going back and looking at my notes because I know I've got that. I added that to the notes this year. I at least typeset my notes for a series of constants. Test for convergence, integral test, p-series, limit comparison. Oh, yeah, n plus 2 to the n. Okay. Or maybe because that one's kind of obvious. Yeah, okay. I'm going to do 2 to the n minus n. Because that's never going to divide by 0. Yeah, that'll be fine. And this one, it's not that the terms are like clearly smaller than 1 over 2 to the n, which converges, because we could just use regular comparison for that one. Here we can use limit comparison. All right, so I'm going to say the sum as n runs from 1 to infinity of 1 over 2 to the n converges because it's geometric. With absolute value of r less than 1, my r is equaling 1/2. I should probably write that, right? Did the geometric series test. Cool, okay, glad to hear it, Hudson. And then I'm going to do my limit comparison, limit as n approaches infinity of the thing I've got divided by terms of the original. Okay, well, like the as n approaches infinity, the 2 to n is going to be much, much larger than the negative n. I could divide through by 2 to the n and like show you this algebraically. I just don't think that's going to be necessary. That's going to have a limit of 1, and that is positive and finite. Okay, and therefore my series also converges. Okay, so as a result, I'm going to conclude that the sum from 1 to infinity of 1 over 2 to the n minus n also converges. Okay, I've got a polar slope, and I'm thinking it's 1108. It's getting close. I'm almost done here. Work here is nearly done. What I will say, alternating series error. I have not forgot about you, Mr. Morales, and that's probably what I'm going to end with, is an alternating series error bound. And yeah, I'm going to do it. And then nothing on you. I just had me thinking about an Anthony from last year that I particularly liked, one of my favorite students from last year. I mean, I know I've got a lot of favorite students, but this guy was cool. Let me see. I'm going for polar slope and alternating series. Or no. Yeah, alternating series error bound. Okay, polar slope. Let's see. We ran into so many of these on the practice exams, I feel like. At least I did when I was working them. So I know where I should go to look for that. I should go to the first round. It's close. All right. That's what I should have done better on tonight, was putting a title at the top of all of my work. But it's okay. I'll get better at the streaming, because I'm going to be doing more of this next year, throughout the year, not just on the day before the AP exam. Of r equals 4 theta at theta equals pi over 2. All right, so this is related to one from a practice exam, and this is going to involve some algebra, right? Just got to be ready for it. dy dx is going to equal y prime of theta over x prime of theta. Okay, y equals r sine theta, x equals r cosine theta. I don't like taking the derivative generally using the product rule. I like to actually make the substitution, but it's all the same, because these problems do always work out, pretty much identically. Okay, I'm going to take derivatives using product rules, so that's going to be 4 sine theta plus 4 theta cosine theta. Move all this stuff over, not get in the way of the others. I'm going to have x prime equaling 4 cosine theta minus 4 theta sine theta. Product rule, like I've mentioned a few times on this stream, it's a heavy hitter. It comes up really frequently, and we got to know it. Quotient rule 2, that's not something I've done on this stream, I don't think, but man. Oh, thanks, MB26. You're on the East Coast. That's cool too. It's only 11 here, so I'm not like keeping my students up too much later than they would normally be up if they are to be believed. I think they typically stay up later than I do. This is actually quite late for me, especially because I'm getting up earlier than normal. But I think after tomorrow we're coasting, right? If we're AP Calculus students, math-wise, I think. I've got a couple of lessons for them to learn about, but not really anything for them to do. All right, so dy dx. Actually, no, I'm going to just find this like right now, y prime of pi over 2, just like as a number. Okay, because sine of pi over 2 is 1, and
cosine of pi over 2 is 0. So 4 plus 0, and that's going to equal 4. And then x prime, cosine of pi over 2 is 0, so that's 4 times 0, minus 4 times pi over 2 is 2 pi. Sine of pi over 2 is 1, so negative 2 pi. And then pro super, I don't know you, so it would be tough to say. If you were in my class, I could probably give you an honest answer and tell you what you need. This close to the exam, I don't have a problem being pretty frank with people. So if you are in my class, put your number and I will tell you. But if you are not in my class and you don't know what I mean by tell me your number, then you need to do some studying and some sleeping. It really is. Jeremy, listen to this Jeremy person. I don't know you, Jeremy, but okay. The dy dx at pi over 2, that's going to equal y prime of pi over 2 over x prime of pi over 2, and so that's going to equal negative 2 over pi. And yeah, that's a good point, Rohan. It does depend on where you live. If you're in Hawaii, I think there's still plenty of time. Now, I don't know if they don't have to get up and take their exams at 3 in the morning. That would be crazy. They're probably on the international version or something. Yeah, because I know that's also part of the reason for the different versions is because the different time zones. I know that you're supposed to take them pretty close to the same time, but I don't know. It might be something for me to ask this summer. All right, polar slope knocked out. Last thing, I think, 2022 Cal BC series question, and let me see if there was any of this in 22. It's not either. Nope, no quotient in there. Oh well. Okay. So f is defined by the power series. F of x equals, that's interesting, I didn't really write as a series. I didn't catch that the original time. X to the 3 over 3 plus x to the 5 over 5. Oh, I think this one's maybe somehow related to log of something. Okay, general term, negative 1 to the n, x to the 2n plus 1, divided by 2n plus 1 itself. Okay, making sure people can see this. One more page, that won't need more than that. Okay, for all real numbers x for which the series converges, using the ratio test, which I did say I was going to do at some point, and sure enough, here it is. Okay, we're going to find the interval of convergence. Okay, so we're going to do the ratio test. Okay, we're interested in the limit of the ratio of the absolute value of an plus 1 to an. But I'm going to just start by doing the algebra and the simplification before I bring in the limit thing. Because once I bring it in, I need to keep it. Okay, so that's going to be negative 1 to the n plus 1. X to the 2 times n plus 1 is 2n plus 1 plus another one is going to be, 2n plus 2 plus another one is 2n plus 3. Divided by that 2n, 2 times n plus 1 is 2n plus 2 plus another one is 2n plus 3. Multiplied, or divided by the terms of the original. Okay, now I'm going to cancel off. Okay, I don't even need to worry about that because I'm taking the absolute value. The 2n plus 3 and the 2n plus 1, there's not going to be anything I can do on that. But I can cancel off 2n plus 1 powers of x there, and I'll be left with 2 powers of x. So I'm going to have an x squared multiplied by 2n plus 1 over 2n plus 3. Now, what's going on here that actually depends on n is this fraction there. And as n approaches infinity, that fraction is going to approach 1. So I'm going to say, all right, well, okay, didn't want red highlighter. I never want red highlighter. The limit as n approaches infinity of the absolute value of an plus 1 over an, well, that's going to equal the absolute value of x squared, which needs to be less than 1. The absolute value of x squared is going to be less than 1 when x is between -1 and 1. So -1 is less than x is less than 1. It's like the interior of my interval. I need to check x equals -1, and I need to check x equals +1. Usually they give you lots of space here, and for good reason. There's a lot of points there. I'm going to be taking, when x is -1, -1 cubed, so plus 1 over 3, plus -1 to the 5 is minus 1 over 5, plus 1 over 7 minus ... I'm going to plug in x equals 1, 1 minus 1/3, plus 1/5, minus 1/7, plus ... Let me make sure I haven't, I feel like I've done something wrong here. Kind of energy's flagging, so I'm just checking off the scoring notes. Okay, no, it's alternating series test. Okay, let me see. Get the third point. No, where's the deal with the fourth point? I don't really give that much information. It's like, do I need the general term down here? I'm gonna just saying I would, if it was my AP exam that determined whether I got credit, I would probably include the general term, but I was able to get by without any sort of, carefulness. These are alternating series. With terms that decrease in magnitude to 0, which is to say they converge, and so my real interval of convergence is going to be that. Okay, and that's part A. I'm going to clear out all this work and get working on part B, because I think that's actually what Mr. Morales, or whoever it was, had requested. All right, so on to part B. Okay, we can get rid of that too. And okay, part B asks us to show that the absolute value of f of a half minus a half, this one I felt like this was kind of a dirty trick, was less than 1 over 10th. Justify your answer. So what we needed to say, what we needed to realize is that f of a half, do that in red, equals 1/2 minus 1/2 cubed is an 1/8 over 3 is 1 over 24 plus 1/2 to the 5th is 1 over 32 times 5, 150, 160. Okay, that's enough terms of actually doing arithmetic. Okay, what we need to see, okay, that's the true value. A half, that's what I would get if I just stopped after one term on the alternating series. Okay, well, f of a half converges by the alternating series test. And again, I might be a little more specific if this was my AP exam, but I'm just trying to get through this right here. And then I'm going to say, okay, well, error, if I just approximate with one term, is the absolute value of the next term. Well, that's the absolute value of -1 over 24, because that was the first unused term, and which is less than 1 over 10. Okay, and that was what we were trying to show. Okay, that's it. That was the thing there. But man, very few students recognized that by that half that I put the squiggly blue line underneath, what they really meant was the approximation after using just one term. I would have liked it a lot better if they said the first, so it would be like, what, 12 over 24 minus 1 would be 11 over 24? To say that that's less than 1 over 100, that would be so much more obvious. Because it would be like, how would I get 11 over 24? Oh, 1/2 minus 1 over 24. Okay, but that's the end of my... I just feel like that could have been a more accessible question had they just made it slightly different. Part C
is there even a part C? Yes, write the first four non-zero terms in a general term for an infinite series that represents f prime. Okay, f prime of x is going to be just term by term. X squared plus x to the 4 minus x to the 6. Okay, I'm going to take the derivative of the general term. The fact that it was alternating did not change. That 2n plus 1 came down as the power and canceled on all of those terms, so I would expect it would happen again. Negative 1 to the n, x to the 2n, and so on. Okay, that's part C. Oh, and then scoring notes. Oh, and I don't know if you're still here. I don't know if anybody's still here. I'm still at 58, which honestly, no, hey, hoax. I don't think. Okay, I didn't understand that question. I, oh, I was talking to a different Owen. Okay, don't understand that question. Hoax, I really hope you don't get a two. I don't want that. I don't know you, but I definitely don't want any twos. I don't like that. But no, you don't have to show the original AB score. I think this is going to show you got a 5 on BC, and that's going to be good enough for 2 credits in calculus. I gotta hope. Okay, 62 people. I don't even know who you are. Hopefully, are all West Coast people. You know, not even close to bedtime. I don't know, whatever. I did part C. Read equals or approximately equals as necessary. Yeah. Then find the value of f prime of a sixth. Okay, we can do that because this is a geometric series. So this is 1 minus 1 over 36 plus, in fact, let's just go ahead and call that 1 over 6 to the 2 plus 1 over 6 to the 4 minus 1 over 6 to the 6 plus dot dot dot. This is geometric, right? The common ratio is negative 1 over 36. Okay, so the first term is 1. 1 over 1 minus negative 1 over 36 is the ratio. I'm going to stop there. That's good enough. You can say that's 36 over 37. I stole that from the scoring notes, but that's all I've got. Alina, don't be stressed. Don't do that. Like, man, yeah, good luck to you, Hudson, and definitely good luck to me. Do you have to show the derivative of the top? Oh man, docket. The short answer to that is that it depends on the question in the year and specifically the question leader. I talked quite a bit about L'Hopital's rule. If you go backwards, let's see, I'm gonna go up, skip ahead to live on my side, and then I'm gonna scroll back. L'Hopital's rule is gonna be discussion on that is about 3 hours and 42 minutes ago. Definitely don't ever say anything equals 0 over 0. The safest thing to do is going to be to show the limits are equal to 0 separately. Okay. Yeah. I would not have retracted that, Owen. I was with you on that. Never say it equals 0 over 0. That's a sure way to get no credit. But if you go back and like where there's the I don't think use L'Hopital's is absolutely essential if you're showing the limits are going 0 separately and then presenting a limit of the ratio of derivatives. That's just like you don't have to call on the authority of Mr. Mean Value Theorem himself. If you just say the beginning and end of it, or just like the conditions and conclusion, that's enough. But you know, if you see that, if you scroll back to where you see a big box at the top of the screen that says L'Hopital rule, they're going to see quite a bit of my commentary on that. That was quite a while ago. Okay, could you go over 1 over the square root is, yeah, but isn't there a 1 over a multiplied to it as well? Okay, so you don't like alternating series test. Well, I'm sorry to hear that, but like, you know, sometimes like what we like is not always the most relevant, you know, like because what I had a student, I think she was working as an aide for me at the time. when she said this about calculus, but she wrote on somebody's paper, she was like, we do what we must. And that has really like kind of stuck with me. We do what we must. Oh, I know what you're talking about on those. Okay. For the arc sign, one, if that comes up, you're best off taking the derivative of the answer choices. That's my honest like feedback on that. Is that a really weird complete the square integral? You're probably, I do like primary colors. That was a surprisingly direct question. I feel like you like maybe you know me. I really do like primary colors. I like primary colors like and like black and brown and gray. Those are ones I like. You know, secondary colors. Those are I let other people enjoy those. Right. I'm not going to talk bad about secondary colors, but I do prefer primary colors. I like that blue, red, yellow. This cat is getting restless. Okay, so I guess it's his time of day. All right. Yeah, I don't think I want to do anything like crazy with arctine. I don't want to give anybody the wrong impression. Like that's something we need to study. That's not a big deal. I've knocked out all the stuff on the list. I'm telling you now. Okay, two things. I've got two things. If this stream was helpful, or you liked it, or whatever, you should like it. You should give it a heart or whatever. Give me those stats. Other than series rules, differentiability, continuity, what does it say? Big justified points on the free response. L'Hopital's rule. Improper integration. Separation of variables. I did none of that in this stream, but my students are doing pretty good. Alina, I think you need to know area formulas. Area of a circle, area of a square, surface area of a cube, maybe? Volume of a cube, possibly? But like things like volume of a cone, volume of a sphere, they're going to give that to you in line with the question. That's been pretty consistent for quite a while now in AP Calculus, that we don't need to walk in with a bunch of geometry formulas memorized, especially obscure ones. I recently learned about some obscure ones when a geometry student just like found me in the hallway and was like, hey, can you help me with this? It was poor choice on his part, but we enjoyed it. Or I enjoyed it. Okay, let's see. Okay, and that was the first thing. Was I was going to ask you to put a like on the stream if you did like it, or you found it useful. Second thing is, if you've got anything, you're gonna need to like speak up quick, because I'm about to call this. Yeah, it's 11:30. Yeah, I'm a fan of a variety of types of chicken. And yeah, I've been known to eat some chicken from Popeye, what I like about them is that you got the fried chicken and the blackened chicken and like roasted chicken maybe. Like I've had a variety of types of chicken from them. But I like chicken a lot, but nobody likes thank you, Jasmine B. Nobody likes chicken. Oh, he heard that. He knew I was coming for him. I've got a friend down here at my feet that just loves chicken, like with all of his heart. But I think he's scurried off to do his own thing. So I think I'm gonna also scurry off. Oh wait. Any related rate problems with d theta dt? Henry, go. Like you've got a free response question. It was in one of the first two rounds. And there's that. I also recorded a fresh video this year on that exact situation. When do you square the polar function when finding the area? Always. Okay, polar area, that's something I can write. Polar area equals 1/2 integral theta 1 to theta 2 of r squared d theta. That's always the case. Okay, so you got your question in. Thank you, Annika. Thank you, Owen. Thank you, Presley. Henry, hold on a second. Because you're here, I'm on my channel right now. I'm just going to go back to the content. And I forget what the video is called. It's like motion along a polar curve or something. Motion along a polar curve. I'm getting the link. Just watch this. It's 9 minutes, 23 seconds. I bet you won't even need that much. Logistic ODE. Ian, I hope you're gone. I hope you haven't been around. 231. So glad to see you. Weakest point to review last minute in the morning. If you're who I think you are, I'd say your weakest point is maybe going to be like making sure you've got the right amount of food in your stomach. You don't need to diet. You're good. Like, the work you have done is certainly enough. I Yeah, I don't know if I would describe myself as jacked. But logistic equation, that's going to be the last thing. I did tell somebody I was going to do that about 4 hours ago. I'm going to remind you that logistic differential equation is mostly trivia, right? There's the form of the differential equation. You do not need to know the solution. Save that for a differential equations class. Number times output variable times carrying capacity minus output value. That's the first important thing to know. You need to know about the carrying capacity. The limit as t approaches infinity of p of t is equal to L. That's the whole carrying capacity thing. Okay, maximum possible value of dp dt. This is the special trivia fact. Happens when p is equal to L divided by 2. There's also a point of inflection there. Oh, physics, mechanics, just better you than me. I mean, I'd like to think I could probably get by on that one. When to restart logistic equation? I don't know what you mean by that, but I'm gonna just kind of write in the last thing that we need to know. There's 4 things we need to know, and the 4th thing is the easiest: the shape of the graph, which I will remind you is one of those, right? It's an S. You're an East Coast student. You're welcome. You know, I assume Rashab. East Coast student, South Texas student, West Coast student. Okay, Sad Nick, I remember that YouTube. Are you? Hold on, you're Nick O, aren't you? Are you Nick O? I don't want to just like blast you with your last name, but if you are if you are who I think you are, glad to see you. Enjoyed working with you. Trapezoidal error. I don't know what that is, so I tend to think no. I've been doing BC for quite a while and grading it for quite a while, so unless unless you're talking about determining whether a oh Creed of course Nick O was 3 years ago. Creed. Okay. Yes, the multivariable. The last time I had multivariable as 2 classes. And oh, I'm glad to hear that, Dan. I'm sure you had the international version or some version of the exam that my students aren't going to have. But if I've got one student coming back feeling positive, that's a good sign. Hopefully, maybe others will be happening or having that positive feeling at the end. This is L, the carrying capacity. That's half of L. That's the shape of the graph. Free response, I can tell you what it was like. It was some calculus. Whoa. B minus A cubed times the max of X. No. You don't need that. I think I know what you're talking about. I think this is like Newton or Simpson approximation. I've seen this before. Very interesting, especially people that like can make a fast YouTube video with animations. I think I've seen something on that before, but that's not something we need to worry about for CalBC. If you have asked for, okay, I think I cleared out. I mean, my inbox is in bad shape. but I did at least clear out all the requests for calculus multiple choice answers. Okay, so I'm calling it, like, we're done. That's going to be all for calculus reviewing. If you haven't been in here the whole, I don't even want to know how long, 4 hours, 37 minutes. If you haven't been in here the whole time, scroll back. There's been lots of discussion, and I'm not going to be taking this down or turning it private or anything, but I am going to be calling it here. So that's all. Thanks to everyone. Special thanks to, like, the students in my class this year, because, like, y'all's hard work has been, like, it's really paid off, especially in the past couple of weeks where we've really made a lot of progress. And I feel good about tomorrow. Pre-cal, I don't even know what to expect. I think we're gonna be fine on pre-cal too. I don't know if I got to make pre-cal in here, but we're totally fine. We've seen the cut scores for that one. We've seen how difficult the class is. We've got this. All right, so that's gonna be all for this one. Thank you, everyone.